Dear all, thank you very much for joining our webinar today. Before we start, we would like to present the modus operandi or the house rules for the smooth operation of the event. Please note that the duration of the event will be approximately 3 hours. To ask a question, please use the Q&A section only. You can either ask a question with your name or anonymously. If you wish to contribute or leave a remark, please do so in the chat function. There will be 2 presentation rounds. Each presentation part will last approximately 10 to 15 minutes. You can write up your question in the Q&A section during the presentations. Our team will select relevant questions and these will be redirected to the presenters for them to answer. The webinar will be recorded. Only what is said and presented on the screen by a presenter and moderators will be recorded, so your questions don't appear in the recording. The recorded version will be uploaded on the European Blockchain Observatory media channels a few days after the event. Enjoy the event. Please let me welcome Mr. Piteris Zilgavis from DG Connect.
Thank you very much. And I'll be less than 10 or 15 minutes because these are some opening words and some opening context for you. On an auspicious day, 2 big things are happening today. I'm not sure which is the greater event. One, the new mandate of the European Blockchain Observatory and Forum publicly commences, in the sense that this is the first big workshop and on a topic that is relevant to what many of us are feeling and thinking these days: health, health and blockchain, health and COVID, health and sharing data, sharing records. So I think this is also something that we can be very proud of as well as interested in. We very much welcome the new dynamism for the new group that is now taking up where the last Blockchain Observatory and Forum finished off. And for those of you who don't know the system, this was not because of any problem. It was because it was a 2-year procurement, and this is the new one. So we thank very much the previous observatory and forum, and this one I think is going to take up its tasks with a great dynamism, as today's workshop already shows. The other big thing, which is coming up almost while we speak, and you'll see on our website and also in my LinkedIn profile, and also probably put something on Twitter. Today is the day that the digital finances package, including the crypto assets and the pilot, the regulatory sandbox, will have been adopted and published and explained briefly by Vice President Dombrovskis, who is the responsible commissioner, working with DG Connect and of course the rest of the commission. The idea here is to give legal clarity and give the possibility to use all kinds of tokenization, also in decentralized ecosystems for things like sharing data or giving access to data, something that will be one of the subjects that we'll be talking about today, so accelerating innovation with third-party data. So in our blockchain strategy, the Observatory and Forum plays a crucial role, as you could say, the knowledge, the think tank. Then we have the European Blockchain Partnership of 29 countries, all 27 EU member states, and Norway and Liechtenstein, who are building a European blockchain services infrastructure, deploying public services across borders, and setting up a regulatory sandbox also to provide legal clarity for all kinds of applications in blockchain, not simply those in the financial area. Also, investments in research and innovation. We also work on skills. We're active in standardization. I signaled to you that we need to be active as Europe in ITU. My unit takes part in the International Standardizations Organization, Technical Committee 307, possibly with some of you with your national hats on. Let's continue this collaboration. Let's make sure that European values are obvious. And then my final words on the legal framework. We finished our public consultation on the Digital Services Act, and there was a part there on smart contracts. We're analyzing that right now, and we want to make sure that smart contracts for health, for finance, for other subjects, that are utilized on a blockchain infrastructure can be used across the entire digital single market and are not fragmented between different member states' rules. So that's our goal. Again, pro-innovation. We're looking forward to your participation here today, of course. We're all looking forward to the great speakers we have, but also the questions, the participation from others who are listening in and here. And so thank you again for your attention, and I'll be glad to listen to all of you today and to see you at future workshops of the Blockchain Observatory and Forum and other events that we're involved in. Now I have the pleasure to give the floor to Kostas Votis from CERF. Thank you very much for your attention.
Good morning. Thank you very much. And welcome all of you for attending this workshop, this first workshop. Let me share my screen, which is about the healthcare applications. One moment. Can you see my screen? Can you see my screen?
Yes, Kostas.
Okay. So I'm coming from CERF ITI. So regarding this workshop, this first workshop, unfortunately a remote workshop, we're going to discuss about blockchain and healthcare applications. So I'm going to give you a flavor of what is going to be presented today. So regarding the blockchain and the distributed ledger technology, I hope that all of the participants, they are very familiar because there are many years now that this blockchain terminology has entered our lives. So with a few words, the blockchain is actually an open distributed ledger technology that can be used for enhancing the trust between the different organizations, can offer different functionalities that are really important. And one of the applications that are being used with the blockchain is also the healthcare. So there are basic fundamentals that are being used, and one of these is that there are different transactions that actually different blocks are changed together cryptographically and support and implement different important features that can be used for the blockchain and through the blockchain infrastructure that give us the possibility for solving many open problems in different domains. There are many surveys, also latest surveys about the blockchain adoption. So what we can see, and according to this Deloitte blockchain surveys last year, we can see that we are moving away from experiments. So now we can see also enterprise-ready solutions. And there are different companies, industries that they are trying to introduce blockchain in different use cases. For solving problems like identity protection, data access, data sharing, and we're expecting also investment within the next years, a large investment within the next years in different sectors and in different domains based on the blockchain applications. There are many architectures, as you can see, for supporting solutions that can be called public or private. So there are permissionless, but also permission systems that have been introduced. So we can see different platforms, public platforms like the Ethereum, or private platforms like the Hyperledger, or other solutions like Corda, Ripple. So there are many blockchain platforms that are being used and are provided in order to be used by in different applications. So what we can see and what we have investigated is that the vast majority of enterprise use cases, we can see that they prefer to use a permissioned blockchain platform. So they prefer to try their solutions in a private network. In addition to what we can see also that some of them are using hybrid blockchain solutions, so they prefer to use a mix of permissionless and permission solutions that can be public and private. So according to the implementation and the platforms, there is the blockchain trilemma, as it has been called. So there are, based on the available platforms and based on the available technologies that we have, there are issues like decentralization, security, scalability. So there are many implementations and there are many attempts to solve many problems that I will explain also later on that are related with the issues like, for example, scalability. There are many applications in different domains, in different areas. We can see that there are domains like energy, like IoT, that they're using blockchain technologies. And of course, it applies to healthcare. So there are solutions, there are implementations on the blockchain that are supporting the healthcare and the pharma industry in order to solve different problems that we can see based on fragmented healthcare solutions, the data anonymization problem, the lack of interoperability and transparency that we can see in different solutions on the healthcare domain. And this is the reason that there are many solutions that can offer different functionalities that they can support privacy management, patient's identity, the interoperability support that is very, very important, but also solutions that can offer KYC technologies for the management of consent of the patients, but also patient incentive programs that can provide benefits for all the people that are and all the solutions that are going to be used on the healthcare domain. So there are many benefits that can support auditability, the operational efficiency that can be offered through the blockchain, but of course, lower costs that can be happened through this automation and cross-border applicability that coming with the blockchain. Regarding the healthcare ecosystem, so there are different entities that are involved in the healthcare ecosystem. So we can see different organizations, different people that they have to be involved. So we can see that in this large ecosystem, the healthcare ecosystem, the trust and the integrity is needed. So this is the reason that the blockchain solutions can support this trust and integrity. Some examples and actually some pain areas about the healthcare solutions that are being offered and how this could support many different areas. So some indicative examples, we can see problems in the clinical trials about data privacy, security, data monetization, for the medicine supply chains, for the documentation, but also for the governance based on the different regulators, the healthcare system. So there are many areas that are very critical and they need solutions in order to support all of these pain points that can be summarized. Some fundamental elements that are required in order to say that the blockchain can transform, the blockchain implementation can transform the healthcare industry. So we can see solutions, as I mentioned before, that they can support KYC, know your customer verification. We can see, and we need solutions for data integrity, the consent and permission handling for data sharing. There are different solutions that can be used for supporting the dynamic consent, the verification, and credentials that are being offered to different healthcare personnel. Of course, the IoT, because now we're talking about smart hospitals, smart healthcare solutions with IoT devices, where we need different blockchain solutions that can support the integrity, but also the trust between these devices. And of course, certifications and the data anonymizations that is important. Some examples that I'm going to present. Here we can see an example of how the blockchain can support it. The vaccination part, where we need to keep records about vaccination in childs and we need to store all the information and try to try to search for any important information that is needed for any vaccination. Medical history management and sharing, we can see solutions that they are trying to offer the data sharing, that especially in situations where we have different and separate solutions, fragmented solutions, that can support patients' diagnosis, treatment, and care. So the medical history management and data sharing can be supported through different solutions that can be implemented in the healthcare ecosystem. The smart contracts, we can see smart contract solutions, patient hospital contracts, or other smart contracts that are being used, for example, in pharma or in different entities like healthcare organizations. So we can have different smart contracts that they can support and they can offer automated, and actually they can increase the automation that is needed in the healthcare. There are also blockchain attempts, and there are marketplaces, blockchain-based marketplaces about sharing data and giving control to the patient. So the blockchain solutions can support even if selling medical data or sharing medical data with any entity that the user, the patient, or any person wants to provide. Credentials verifications for physicians or for other users. So we can provide solutions for verified credentials information among different healthcare institutions, among people or personnel, healthcare personnel that is involved in the healthcare ecosystem. So we can see solutions that are support this verification. Data transfer between different devices, health service providers. We mentioned also the IoT, as we have different IoT devices, medical IoT devices. So the blockchain can enable secure recording, transmission, and sharing between different devices, between different health service providers, and there are solutions for trying to support this data sharing. Dynamic consent management, very, very important in order to manage, actually managing dynamically the consent for the patients, and try to be sure that the patient is really familiar and is really informed about the consent that they are giving in different situations and in different clinical trials that may participate. Medication adherence, a platform that is being offered by a company, GuardTime, that they are can ensure patient data integrity and provenance, and they can automate the verification of medical adherence. There are many solutions that they are trying, they are attempting to improve the medication adherence. Hospital admission solutions like this one, the form drop, that can offer index patient's ID and personal health information on universal patient index. So using smartphones and using blockchain solutions, the patients, they can complete forms remotely, and everything can be monitored through the blockchain. Drug supply chain and blockchain solutions that are being used, and that are going to be offer very many benefits to the pharma industry. Other solutions that are coming from US or from other European projects and European implementations, Gatekeeper based on solutions for large-scale pilots with blockchain, Savaya, Simply Vital Health, about creating and try to use blockchain technologies for different solutions, but also other projects. This is MyRecoach projects that we try to integrate actually blockchain and try to offer a permission handling solution for asthma patients. Pharma Ledger, please be patient for the next presentation that is going to be present, Pharma Ledger and how blockchain technology can be integrated in the pharma industry. However, we need to understand that the blockchain implementations and the blockchain attempts that are happened, it's not very easy. There are different limitations that have to be alleviated. There are many solutions, many platforms that have to be interoperate. Different smart contracts or data sharing has to be implemented in a specific manner in order to support and try to be sure that there is interoperability issues that can be solved. The scalability issues, we can understand that there are many scalability issues, hardware performances, blockchain also limitations that are coming from the different available solutions that exist. And this is something that has to be analyzed and has to be discussed. And of course, the regulatory, GDPR, all the regulations that are really, really important. And this is the reason that there are many EU, there are many attempts from the EU in order to solve many regulatory issues that they can be needed in order to be sure that all of these blockchain implementations can be efficiently implemented in the healthcare ecosystem. Thank you very much. And now I give the floor to the moderator of the next session, Mr.
Kostas, apologies for interrupting. There are some questions for you in the chat if you would like to look into them and respond before we give the floor.
Many challenges requiring many stakeholders to be activated, the action and development of the solution, hospitals, pharma, doctor, patients. What are they going to create the application? Thank you for this interesting question. Of course, there are many challenges that they need to be. They need the involvement of all the ecosystem because there are many implementations. But the problem is that if we don't have the overall ecosystem, and if we don't have, as I mentioned in the last slide, some problems that have to be solved, some regulatory, also governance problems that have to be solved, then it's not be possible any of this application to be activated and to be used. So of course, we need to involve all the ecosystem. Who is going to pay the actual development? I think that depending, there are many attempts also in national countries that they are trying to integrate solutions, and they are trying to offer solutions that I think there are some governments that are trying also to pay for this development of the solution. So for offering a solution that can be freely available to the ecosystem, the healthcare ecosystem, like the patients or the doctors.
Okay, thank you. We can proceed then. Please, Kostas, give the floor.
Yes, I will give the floor to Mr. Gerasimos Michalitsis, the moderator of the next session.
Hello, good day. I'll be moderating the next session, which is about actual applications and discussions and problems for upscaling further development of the blockchain. As I think we all understood from Kostas' introduction, blockchain is just a technology. It does not create value by itself. It has to be applied in specific use cases, leveraging maybe the trust, the immutability, the transparency that this technology may provide. I believe we will hear such cases in the following presentations, and I'm looking really forward to. Please use the Q&A section for posting questions. We'll be having a 30 minutes slot in the end of the presentations in order to address questions for all presenters. And I also wanted to ask the presenters to try to respect the slot in order to let us have an interactive conversation just after the presentation. So thank you very much. I'm passing the floor to Sinika and Marco. I'm not attempting to say the last names. I will be maybe do very big mistakes. So from Novartis, Sinika and Marco will go on with Pharma Ledger.
Okay, I'm sharing the screen. Can you see it? Okay, good. So then let's start. My name is Marco Quom. I'm from Novartis. I'm located in Switzerland. I'm an architect working in the architect group of Novartis. and there I'm responsible for blockchain for the last 3 years. I'm also co-leading the architecture workstream in Pharma Ledger, which we come in a minute, together with Seneca. And I hand over to Seneca to present him quickly.
Hello, everyone. My name is Seneca Alboaie, and I'm representing RomeSoft, a software company located in Iași. So in Pharma Ledger, I'm representing RomeSoft. I'm co-leading Pharma Ledger architecture together with Marco, but I also am a technical leader in another European research project called Private Sky, a 5 years project in the University Alexandru Ancuza from Iași. In the last 10 years, my interest as a researcher, software architect, and product manager evolved around privacy-enhancing technologies and gradually to blockchain technologies and self-sovereignty. Marco, please continue our presentation. Yes.
Oops. So here's the disclaimer to make our life a little bit easier so we can talk more freely. So that's out of the way now. Let's have a quick introduction to Pharma Ledger. Before I come to Pharma Ledger, the project, I give you the umbrella around Pharma Ledger. So Pharma Ledger is part of IMI. IMI is innovative. It stands for Innovative Medicine Initiative, and is the partnership between the pharma industry, FPIA, and the public, in this case, European Union, and it's funded with 5 billion for the last, let's say, for the last 12 years. They run roughly 120 projects, and one of these projects under the umbrella of IMI, most of them are medical, is Pharma Ledger, blockchain project. So what is Pharma Ledger? Quickly, in a few words, it's a partnership between different, between the industry and public partners. In the public partner side, we have universities, hospitals, startup companies, and others. And on the industry side, we have 12 pharma companies, the top 10, and a few others. The goal is that we empower the patient with Pharma Ledger. So you heard maybe the sentence, the patient should control the data. We want also to create a trust in the healthcare industry to improve that, and in general, increase the collaboration in healthcare to speed up development of new drugs, but also the access for patients to new drugs. How we want to do that? The idea here is we want to build a blockchain platform to do that, to enable that in a very flexible way. So this is basically the idea. And to show that this platform is working, we focus on 3 reference implementation of use cases, or 3 areas of use cases. On the right side on the screen, you see the few focus areas. It's supply chain, clinical trial, and health data. I think I covered most of it. Yeah, it's about a 3-year project. The big challenge will be after the 3 years to make sure that it's sustainable, but we're working on that right now. Next slide is for you, Seneca.
Sorry. Pharma Ledger is a blockchain-based platform, and it will be successful only if you demonstrate reduction of cost or will create new opportunities for the healthcare ecosystem. It's amazing that we have so many big pharma companies inside of our consortium. So this is different from many other European projects. We have a great opportunity to advance also the self-sovereignty revolution that is happening now. In areas of self-sovereign identities, but especially in areas of data self-sovereignty. In this presentation, I will talk more about the technology side of the story, but the business side of the blockchain internet enabled internet for healthcare is pretty clear. New collaboration, even between competitors, could emerge. Better security, auditability, interoperability can emerge. And there's a tangible opportunity to advance the medical science using the patient's private data. In Pharma Ledger, we have on our radar 9 different use cases. currently at least, real use cases coming from pharma companies. And we are covering areas such as supply chain, health data marketplaces, clinical trials, IoT, dynamic consent, and so on. I will let Marco to present the most advanced one, the e-leaflet.
Thank you. So the e-leaflet, it's also called EPI, Electronic Product Information. We start with the e-leaflet, but this is just the foundation. The next steps will be then really unfolding the full power. So what is e-leaflet? You all know when you look here on the left side, on the left side, you have in each medicine, in each package, you have a huge paper description, how you apply the medicine, the side effects, etc. I think most of you know that, and most of you never look at it. But it's a crucial element in it, and we should not underestimate how important it is, because the dosage is in it, and a lot of other things. It's a full process. It's not only paper we print at the end of the process. It has to go through an authority. It needs approval, and so on and so forth, because a little typo, 1 milligram or 1 gram, can make a big difference. So we need here, of course, a very rigorous control of it, and there is high regulatory around it. So the idea now to bring that on blockchain is basically not new, but is the first step for giving the patient more control over the medicine. When you see here, we have some wireframes from how we see it. So it is not only the e-leaflet you will see, you will have also more possibilities. The next step would then go in a direction to say, how can I make sure that this product I have in hand is authentic, or is not a counterfeit, and so on, or is it already expired? Is there a recall? Are there other informations which I need to know? And all the things have to go through regulatory, and the patient should just use it without thinking about it. But in the back end, there must be a lot happen, that the data are really, that the integrity is guaranteed, confidentiality is guaranteed, and a lot of other things, because the patient doesn't want that the pharma company know what we do and how we use the whole thing. So this is our first use case where we accelerate in Pharma Ledger, and the goal is that we have a first version, an MVP, minimal viable product, by end of this year. And as we are IT people, let's be more realistic, at least in January, February next year. But the goal is still to deliver by end of the year an MVP, which is showing that the basic concept is working, the technology is working, and yes, the e-leaflet is also presented. But if we have that in place, then we can unfold it to the next steps, as I mentioned already, and the counterfeiting, and there is much more possible. So this is the first thing. Overall here is very important, the privacy. We want to make sure that the patient feels secure and not has the feeling that somewhere in the background all his or her data are collected and somehow abused. This leads me to the next point, a little bit a shift gear here. I would like to start with a kind of a phrase, you already heard it. I mean, if you don't pay the internet services, then you are most probably the product, means somehow has to pay it. And as I told you, the EPI should be for free for the patient. So we don't want that the patient has the feeling that he has to pay in one or the other way. So, but even that sentence is maybe too simple. And I just quote here Jaron Lanier, it's the gradual, slight, imperceptible change in your own behavior and perception that is the product. So you all heard about it, about Facebook and Google, how they influence us with the ads and so on. And this one is a quote out of a very interesting Netflix documentary showing called the Social Media Dilemma, and shows a little bit what all happens with your data. And this is what exactly want to avoid with Pharma Ledger. We don't want to be perceived as something like a big data collector like Facebook or Google. So we put a lot of emphasis on identities, privacy, confidentiality, etc. This is an extremely important topic for us because we want to gain the trust of the patients in the healthcare industry. This is our goal, and we have to do something for that. But I let now talk Seneca about the next points.
Thank you, Marco. In the next, I don't know, 4 or 5 minutes, I will stay on this slide, and I will talk more about blockchains, but especially about self-sovereignty technologies that we plan to use in Pharma Ledger. We can see that many enterprise solutions in the blockchain industry is busy and focused and copying what is happening in the cryptocurrency world. And sometimes it's fascinated, maybe too much, on different inventions, for example, zero-knowledge proofs. All these innovations are good and interesting and cool, but in Pharma Ledger architecture, we take the approach of not believing that one size fits all. Therefore, we plan from the beginning for a multi-blockchain approach, and we work hard to create documents, best practices, about what kind of blockchain technology and what kind of approach is appropriate for a specific use case. From our past research efforts, we got some exciting and somehow unconventional new insights that come together under this concept of OpenDSU. We currently plan to use OpenDSU to cover like 80–90% of the healthcare use cases that we have in Pharma Ledger and beyond in Pharma Ledger. But as I said, we want to maintain an openness to introduce new architectures, archetypes, and to adjust the code of the OpenDSU implementation. So we let it open to different new innovations. We aim to create an open platform that can be continuously improved and optimized for real-world challenges. Basically, the OpenDSU is coming from data sharing unit idea. So it's a way of structuring data for sharing, let's say. And it's a simple approach in one hand, because we say that you can put data and code together and anchor this data and code together in blockchains. It's relatively easier to explain to programmers when they see the code, but we found that it's simple, powerful, and immediately useful. The code, the anchored code, is similar in a way with the code of the smart contracts, but the important shift is that this is off-chain code, and we are talking about off-chain data and not on-chain data and code. So that is making OpenDSU approach blockchain agnostic. We can use any blockchain technologies, and OpenDSU technologies are about off-chain storage, off-chain kind of smart contract platform. We even call this secret smart contracts because not everything is shared. Not even the patterns of activities are not shared with the inside of the main blockchain. And in other difference and innovation that we promote with OpenDSU is that we want to go to see a world that goes beyond the current state-of-the-art architectures that are based mostly on web APIs, web services, microservices. Relying on web services automatically leads to centralizations. The technology choices can lead to monopolies and to creation of companies as Facebook and Google, to just name two companies that are identifiable by most people as enemies of our privacy and as dangers for democracy, freedom, and so on. Blockchain promises to offer an alternative, but it's quite difficult to change the people's minds and their past experience. It's hard to teach architects and programmers to go beyond the client-server mindset and big databases-centric architectures, and embrace decentralization and peer-to-peer approaches. So in a way, we are fighting a bit. We see it every day with web APIs way of thinking. We have to go beyond because it's hard to get confidentiality and security if we continue to use the same mindset. Especially the enterprise architects, when they use blockchain, they have the wrong experience and the tools available, and they cut the corners and they come with wrong solutions from my point of view. Let's talk a bit more about this concept of data self-sovereignty. It's relatively new direction and relatively poorly addressed by the community. The major focus now is, if you see conferences and everywhere, is about self-sovereign identities. The problem with self-sovereign identities is that it's too limited and cannot, from our point of view at least, it cannot achieve his goals if the data self-sovereignty is not addressed. And we'll see more. Also, we have to address the applications themselves, how you control, how you deploy, how you work with these applications. Self-sovereign identities looks like a quick win, and it's probably easier to find some use cases. But especially for the Pharma Ledger use cases, we find that it's not enough. People and companies are storing significant amounts of sensitive data online, such as trade secrets, customer information, personal identifying information, pictures, and so on. Typically, this data is not properly protected and is shared with too many people. With even if the companies have inside some processes and so on, is still vulnerable to internal attacks, to oversharing, let's say. The data sharing units are coming with new solutions and new approaching to this problem to protect privacy, but also to protect companies from data misbehaves. I think so. The current approaches is that we put too much data in databases. You cannot really protect from the technology this data. Copying data can be solved 100% by technology, but a better way of organizing data around sharing constraints could help, we believe. So some legal tools are required, but the current habits of putting everything in big databases, because it's so easy to run queries, should be challenged, and we challenge it, and in many cases stopped, as it's against our own good as society or as companies. OpenDSU proposes a method of storing and sharing data that reduces, in most cases eliminates, the trust in storage provider by pushing a world where we use more client-side encryption and not trusting these web services that we are used so much with them. And I think this is the right direction, and the single chance to achieve the proper data sovereignty for citizens and companies. When data sovereignty is applied to the data belonging to the organizations, let's say data containing trade secrets or other processes, we are talking basically about good security. Data sovereignty is about reducing also the risk of internal attacks, of unintended data leaks. Yeah. So this is it's quite important for us to say. My personal bet is that technologies promoting self-sovereign identities will not succeed without solving first the difficulties around data self-sovereignty. In the end, it's quite hard to see how the self-sovereign identities will work without having proper control on applications, as I said at the beginning. So when you think about OpenDSU, it's a technology that is hoping that will create killer applications. Let's say about something like email, or maybe in the areas of medical data. We have a great opportunity with Pharma Ledger to create such killer application that will push the best practices and will make these approaches mainstream.
Sinika, if I, excuse me for barging in, if you can wrap up because we are...
Yes, yes. Marco, please present it. You have only 2 slides more, so.
Yeah, okay.
I talk a lot, yeah.
Okay, so no, I put your ease on mind, no problem. This is a quick overview where we use the nomenclature from the GDPR to give a quick overview where we see the OpenDSU positioned as Sinika explained before. I will not go here in the detail, but just focus a little bit on who we are looking into it, the data subjects. This is nomenclature from GDPR, are peoples and companies. They have confidential data. These data has to be controlled via digital wallet. The digital wallet can be part of a server application, a legacy application, but it can be also part of a mobile app. And in between or there you have then the data sharing units, the confidential data, which in the back end are anchored in the blockchain. And the company or the people, they give the consent, the contract for data processors who then can work with the consent of the owner of the data, doing then some data exploitation or work on it. This is basically, as I said, the nomenclature from the GDPR. So our concept fits perfectly in that concept. And the last slide, and I will not stay on that one here, is our vision where we say in the future, it's a little bit big, I see now, but in the future, we see that all our confidential data and this kind of thing will be managed by a digital wallet. This digital wallet should be interoperable and portable. This is not the case today. Today, you have to manage tons of different mobile apps where already they cover some of the wallet functionality. They are not interoperable. They're not talking to each other, and they are also not portable. You cannot change one app for another. For example, you cannot move so easily from Google Pay to another payment system. I mean, you cannot import, export, or export, import the data. This is our vision. As I said, in the future, we see a lot of things going through a digital wallet. The digital wallet is not necessarily a separate application. It can be embedded in a server legacy system or in a mobile app. It depends on the use case. It depends who the user is. There can be a company, there can be people, etc. So I'm closing with that. And thank you for listening. And I'm handing over back to Michaelettis.
Erasmus, you can call me Jerry. This is the easiest thing. Thank you, Marco.
Yeah. Thank you.
Thank you, Sinika. There's no time for questions right now, but just an easy one or a couple that I'm seeing that I can be answered, I think, easily. Is anything related to Pharma Ledger in actual use right now is one question.
We at the moment, in all the things we have presented here will be part of Pharma Ledger. So we are in the process of developing the whole thing. So we started beginning of this year, and the goal is to have by end of this year the first application up and running with the full blockchain and everything behind it. So it's not productive yet, but it will be a first MVP. Will be soon there, but yeah, it's coming. It's coming.
Yeah. It's clear. It's clear. And another one, I think it's the answer will be yes, I'm sure. Would Pharma Ledger be interested to see what type of applications other teams are developing in relation to SSI or verifiable credentials based on INDI or ARIS?
Sure. We want to integrate the DIDs and verifiable credentials. So OpenDSU is a very thin layer which supports any other identity tools, in this case DIDs, but also X509. So yes, we will support that. And even for the EPI project, we will do that exactly. We will use these DIDs and verifiable credentials as part of the EPI project. So yes.
So thank you again, Marco and Sinika. I'm passing the floor to Dr. Wendy Charles. This is a much easier name for everybody from BestIQ to discuss BestIQ blockchain for surgical costs and outcomes. The floor is yours.
Thank you very much for inviting me, and I am pleased to present today. I'm going to start by sharing my screen. Okay, and I will create the full screen view. Okay, so I will present a demo of actual healthcare software that was built on top of the BurstIQ blockchain for the last 3 years. I will first share some brief background of the history so that you can understand why this was designed and what were the features. So I work for BurstIQ. It's a blockchain company that was designed from the ground up to store sensitive healthcare data on a platform as a service. Now, of particular note, the company was founded in 2015 and has had a blockchain in full production since 2017. And our clients store healthcare data on chain. And this blockchain is reviewed by independent auditors as being HIPAA and GDPR compliant. So the project that I will talk about is a partnership with Empiric Health, which is a spin-off company from Intermountain Healthcare, a large hospital system in the Western United States. Now, the goal of the project is to reduce clinical variation in surgical services. And most healthcare organizations don't know how much a surgery actually costs or how costs are associated with quality. And Empiric Health needed a way to combine and compare information across hospitals and surgeons so that they could better engage surgeons in best practices to improve quality and reduce costs. Intermountain turned to BurstIQ for help in aggregating the clinical documentation, claims data, surgical supply chain, quality analytics, staffing details, and information gleaned from free text dictated notes. And data from all of these sources were then added to the BurstIQ blockchain using a data ingestion engine that automatically adds metadata and reformats data to a common standard. And in addition to be able to aggregate disparate sources of data, the blockchain was necessary for smart contracts and rules engine. And we refer to smart contracts as consent contracts because most organizations don't understand what smart contracts are, and because smart contracts are not necessarily smart or contracts. And the orchestrator creates maps and data matching, which automates workflows and data exchanges. Together, we created visualization tools so that different sources of data could be pulled together on the same screen for deep reviews and analytics. And the cost of every single surgery could be calculated accurately down to the dollar. And Empiric Health, together with their physicians, grouped surgeries by severity and comorbidities for an apples to apples comparison. And over 3 years of Empiric Health's efforts to analyze surgical costs and quality that they could only do by using a blockchain, Intermountain Healthcare was able to save $90 million in the following areas. And Intermountain Healthcare researchers were able to access pseudonymized data to conduct research. So now I will show you the actual product. So this is a screen that shows the visualization tool that has been determined by filtering information about specific surgeries and facilities. And in this, we see that this is for a particular surgery. It's lab cholecystectomy, outpatient, and I'm only showing 3 different hospitals. The colors show the different hospitals. The size of the circles show the volume of surgeries, and the average shows the cost. And so for this particular example, the analyst would say, why is hospital V so much higher than the other hospitals? And looking at these anonymized and fictional surgical names for this particular demo, we can see that 2 surgeons in particular are the highest. They perform a lot of surgeries, and so it's worthwhile to ask, what are they spending money on? Information from the blockchain is converted into a data table where there's the ability to select columns and analyze data on to determine how far the average is from the, how far each surgeon is from the average. And it's possible to determine the standard deviation to look at different ranges. In this particular example, we can see that the highlighted information is for surgeons who are 2 standard deviations above the mean. And for a fictional surgeon named Dr. Capps, for example, as we look at some of his surgery costs, we'd say, wait a minute, why is he spending so much more money on surgical products? And it's possible to drill down and pull information directly from data stored on chain to be able to examine specific costs and understand exactly how money is being spent. Now, in going back to the graph, it's possible to change the views on what we are looking at in order to understand if there are factors that might influence. So for example, this fictional Dr. Capps might say, well, my patients are sicker than other patients. And so we can look at American Society for Anesthesiologists physical status scores and look at different surgeons across this range to see how that varies, or also by payer. And again, to determine where there are outliers. It's just possible to look at across efficiency measures, such as how quickly a surgeon was able to complete, whether they were under anesthesia for less time or there's a shorter length of stay. And we can look at every possible dimension for this type of surgery. There are other visualization tools that show different features of what the organization was interested in looking at so that they can really drill down into the data to understand better. And any of these graphs can also be pulled up and to look at specific surgeons and drill down to those to get a better granular view of those costs. And it was a little slow because this is pulling directly from the blockchain in real time. So what would happen after they've accumulated as much data as possible about individual surgeons is that a surgeon member of Empiric Health would then sit down with the surgeon in question and show that surgeon his or her results compared to other surgeons. And it helps the physicians and other clinicians to see and understand how these tools create standards that lead to better outcomes for their patients and increases level of accountability for outcomes in their health system. So overall, the blockchain and the visualization tools enable a meaningful examination of costs and outcomes. And as I shared earlier, for one hospital system alone, even though this has been used for many, many hospital systems, but for Intermountain Healthcare, they saved $90 million in 3 years with better clinical outcomes. So I am happy to answer any additional questions that you have in the panel discussion, and I will turn it back to our moderator. Thank you.
Thank you very much. Thank you, Wendy. Thank you for keeping the time as well. We don't, at least 3 minutes ago, we didn't have any specific questions yet. I'm sure that we will have, and I have some, but I would prefer to move to the next speaker, which is Ingrid Vasiliou, I would guess.
Ingrid is fine, don't worry.
Thank you about this, who will talk about opportunities and challenges in deploying blockchain solutions globally. And I'm passing the floor to you. Thank you.
Thank you so much for inviting me. It's a great pleasure to be here and to share some of my insights. The reason why we chose the topic of this presentation for my portion is because of my role. In the healthcare arena, I have the opportunity to interact with several hundred facilities, not only in the United States, but also globally. I also have been on the academic side for 13 years, and then I moved over to the private sector. So that gives me a very nice 360 view in healthcare. And then On the not-for-profit side, I interact globally with more than 90 countries that have deployed blockchain for various industries. So we thought it would be helpful and valuable maybe for the audience to hear what is happening on a global level, what do we share in terms of opportunities, not only in healthcare, but also across industries, and also what challenges do we still face. And maybe if we break silos, not only for healthcare, but break silos also amongst disciplines and industries, we can achieve a better state. So I'm gonna start by sharing the screen. And then also maximize the screen. Let me know if you can see it. I'm gonna now maximize for full screen view. If there's anybody that can't see it, please let me know. So again, the global landscape, we're not gonna talk about each element on the slide. I'll just provide a high level and accentuate on each slide what I think is essential. I think this just gives you a very nice full view of all the governments across the world that are using blockchain for various reasons. I think we can see there are tremendous efforts. However, we still have a lot to go. From an opportunities perspective, something that fits every country and every industry, obviously advocacy, literacy, privacy, cost reduction. We're all working towards financial inclusion. Digital economy is something we're all facing. And two that are very near and dear to my heart is purpose and sustainability. If I had to pick one on this slide that for my role has been clearly the major opportunity, and I think we're gonna touch on it today a lot, is privacy. There are opportunities that are unique by region, and I've split these up in two. Countries with more advanced blockchain strategy and legislation already, I would say we can already focus on some more sophisticated elements, such as promoting larger scale adoption, enhancing interoperability. I really have to emphasize performance optimization. Just deploying a blockchain and being happy that we deployed is not enough. I think we're ready now to enhance performance. Development of certifications and quality control mechanisms. I see that a lot. I did compliance and auditing for about 10 years of my life. So I think that's another major aspect that I see, that, okay, we overcome challenges, we adopt blockchain, but then people forget to do quality control and process improvement. And I think that's gonna be the next decade. Creation of centers of excellence, same way like we've done in other industries. After we adopt and deploy, we have to then start defining what does excellence in blockchain adoption mean. And then of course, research and certifications for various industries. For countries that do not have any blockchain strategy yet, there are other elements that I think we need to work on. Of course, advocacy, clarifying what digital identity elements we all want to agree upon, dynamic consent, which we're going to talk a little bit later, blockchain literacy and fluency. There are many countries where you say the word blockchain and no one knows what that is. Education and training. And when we talk about education, we're talking about already at high school level, undergraduate level, and graduate, if we really want to think about the next decade or so. And then, of course, encouraging blockchain deployments for specific industry in these countries that do not have anything yet. The challenges that I see universally, regardless of domain, so not only in healthcare, but all industries and also globally, are the ones that you can expect. If I had to pick two that have been the biggest issue in my encounters were, again, privacy. And I would say the issues in terms of lack of harmonization with policies in each country. I think those are the ones that are causing the biggest problems right now. If I would summarize the lessons learned, I would say I learned the very hard way to not use the word blockchain. We have to use all other elements that define a blockchain or ledger technology, but just don't say the word blockchain because that sometimes causes confusion. I also would like to emphasize that strict proactive data governance prior to deployment is crucial for success. addressing the crypto myth up front to clarify any miscommunication or confusion or lack of clarity or bias against cryptocurrencies is also important so that people can focus on what's meaningful when we talk about ledger technology. I would also say that in order to achieve larger scale adoption, maybe considering industries where the ROI is higher and easier to achieve can help push for mass adoption and getting some of the standards solved. I also felt that over the past few years, addressing the major pain points for each industry helps, as opposed to just focus on beautiful use cases that sound scientifically interesting or fit the technology. And then, of course, to get better at proving the ROI, the return on investment, because that's a major hurdle for large-scale adoption. And last but not least, again, something very near and dear to my heart, developing key performance indicators real time of what it means to have a successful blockchain adoption is also important. You see it across the globe now, people deploy blockchain and forget to have any type of quality indicators. And then after 1 year, when you try to show the value of that project, it's very difficult if you don't have these real time. So we talked a lot about the challenges and lessons learned, but there are also some elements that can drive success. And again, advocacy, leveraging science institutes and technoparks globally helps as well. My favorite one is doing a very strict feasibility analysis. I think the challenge has been over the last few years that it was so difficult to overcome resistance of adoption that everybody was very happy if they found someone that wanted to deploy a blockchain. And I don't think that's a very good long-term sustainable approach. Having strict feasibility analysis and proactive data governance will ensure success long-term. I also think doing a proper failure mode analysis before accepting projects is also a very good approach. Human capital, training and development in time, not just deploying the blockchain and then trying to deal with the human capital problem is also a key element of success. Conservative financial projections, instead of trying to overblow them, has also been, I think, globally a big issue, and particularly for healthcare, definitely. Very few people have facts that they can use, so the projections are usually rough estimates. Realistic timelines, like was already mentioned, and then, of course, addressing some of the largest hurdles and vehement opponents early in the process. And now I'll spend most of the time on 2 slides that are healthcare specific, which is our focus today, but I thought it would be good to see that many of the challenges we face in healthcare cross industries. So our goal today is to hopefully be able to highlight the fact that if we understand that some of the challenges in healthcare are not unique to healthcare, we can really work together across industries. So as a summary over all my experience globally, I think there are 4 elements that can help us work towards a more collaborative approach and have a healthcare ecosystem powered by blockchain that can show value long term. Clarifying all the elements that are related to digital identity, and I'll talk a lot about that a little bit later today. Informed consent, all the elements that are related to informed consent, and Dr. Charles will talk about that also a little bit more later. And then the other 2 that are crucial are healthcare exchanges and interoperability. When we do talk about healthcare exchange, I want to highlight the fact that we need to talk about healthcare delivery, research, and then all the other elements that are related to delivering healthcare or research in the ecosystem. There's many other industries such as pharma, like we already heard, blood management, any other laboratory devices, medical supply chain that have to be considered. You cannot think about healthcare in a vacuum. There are many other industries that will need to be considered when we talk about healthcare exchanges. Similarly, the financial payments. At one point, we have to also understand that there's a big overlap between when we think about digital identity and informed consent with financial payments industry and healthcare industry. And if we don't address those early, we'll have major interoperability challenges down the road. I also would like to emphasize that from a healthcare exchange perspective, being able to have a more granular approach and a more dynamic approach for all the elements that are related to healthcare, as well as all the domains within healthcare, is really crucial. And to give examples, what you might need for a primary care appointment is very different than what you need in oncology or for precision medicine solutions. So we need to start thinking in a more three-dimensional or multi-dimensional fashion in order to solve these. Right now, what we see globally is that you have either too strict control and then you focus too much on privacy, but then you can't deliver the global healthcare and population health that you would like to, or vice versa, that we don't have enough concern about privacy and then you can do a better job maybe on delivering the healthcare and research that you want, but then you violate all the issues that are near and dear to our heart from a privacy perspective. So the way I like to conceptualize this from a visual perspective is like spheres, thinking about privacy, healthcare delivery, doing research, and interacting with multiple industries has to be multidimensional and like overlapping spheres. You cannot think about it just in a bidirectional flat way. Otherwise, you're always gonna end up with challenges and lack of ability to sustain whatever you're trying to achieve. And then from an interoperability perspective, it's the same concept. When we talk interoperability, it has to be intra-organization interoperability. You cannot just deploy the blockchain for one simple system within that institution. You have to think about how that application will function with everything else. And that's the major challenge I've seen in healthcare. You might have it deployed for electronic records or for surgical procedures, or for pharmacology or for blood management, but then it does not interact with everything else that's being done in that healthcare system. Similarly for research, sometimes organizations just agree to deploy ledger technology or blockchain for an isolated element within the research lifecycle, and then you're gonna not be able to integrate it with everything else that happens in the research journey from a patient perspective or from the scientist perspective or from the organizational perspective. So when we say interoperability, same thing, we have to think about a multidimensional approach, intra-organization, and then amongst organizations. Every organization functions in an ecosystem as well, and being able to share data appropriately amongst organizations will help not only patient care, but also help promote global health and population health long-term. The second slide that I would like to hone in on is regulatory policy and legislative recommendations. Of course, we can have a workshop only on this, but I wanted to highlight a few elements. The overall harmonization from a healthcare ecosystem perspective is really important. And what I mean by that is we have to work together, not in silos, but together really from a legislative perspective and from a regulatory perspective and policy perspective to address scientific research and healthcare delivery, as well as medical supply chain, pharma, and laboratory services. Otherwise, it's gonna not work long-term. Data ownership is another big issue. There are many legal and other elements that are related to data ownership that need to be addressed. Accountability and liability for smart contracting. Healthcare specific standards and certifications are crucial, I think, for long-term success. And then the architecture and infrastructure we decide to build will also be super important for us to work together on. Right now, it's all completely fragmented. So I noticed there are a lot of questions coming in, so maybe I should take a quick peek at those.
Thank you, Ingrid. Thank you for this. I was discussing now with the administrator that we may have to skip the break. So we will have time to discuss, I think. And I will use this opportunity to ask one question to you, if possible. And the question is, which organization do you think that would be most prone, or some would be most successful to start with for applying a blockchain network? Would it be governments? Would it be federal governments? Would it be specific associations? Or would you think that someone has to begin with a couple of players, two at least, of course, in order to set up something, and then the rest will join when they see the value?
I think it depends on for healthcare. I think it would be helpful if governments take the lead, just because of some of the elements we talked. You have to have harmonization between legislation, regulatory, and legal guidelines, and I think it's going to be very difficult for an independent organization to address those at the same time. Similarly, because of some of the key points I emphasize, such as digital identity unfortunately applies to many other things that we do, such as finances, voting, legal and real estate. So solving some of those things, I think, unfortunately, has to be part of government as well. However, I do think that independent organizations can contribute a lot. So I would say, if I may, that a collaboration between governments and not-for-profit entities or independent entities is probably the best approach.
Okay, thank you for this. And as you touch this topic, I will make another question that is coming from the audience. Does it make sense to have a golden copy of a client's KYC data, given client's consent, between healthcare organizations, hospitals, and insurers, regulators, so that this data set is always up to date and can be monetized by the institution that updated and verified the data?
I hear two questions there. One is, does it make sense? I think yes, and in the second part of the presentation today, we'll talk a lot about like the concept of digital twin for healthcare. I think it could be valuable with appropriate safeguards in place, but I think the monetization, that's a different layer. I think definitely there is a big value to have a golden key, but the monetization, I think there are pros and cons.
Thank you. Thank you. Okay, let me pose a question from my side as well to Wendy and the gentleman from Pharma Ledger. And let me know which is the single or maybe a couple most important benefits that the blockchain technology provided in the solution that you presented. And why can't traditional technology, like, I don't know, centralized encrypted database or distributed encrypted databases or other such solutions, supply such a solution to the customer? This is, I think, a general concern of people that are addressing the blockchain technology. There is a lot of dispute sometimes when we see value, that this value may be implemented by other type of technologies already there. So let us discuss a little bit, which is, where does blockchain benefit your solution specifically? And let's start from Wendy, let's say, from which I see.
Yes, thank you for that question. So our partner chose to store, let me back up. First of all, anytime healthcare information is going to be stored anywhere, it needs to be in a private setting. And so therefore a private permission blockchain was selected. The reason why our partner specifically selected a blockchain for their needs is that they needed to have the capabilities of smart contracts for automating some of the ingestion process, as well as automating some of the access. They really needed the granular consent capabilities and the complex ownership so that multiple organizations could have access to data for analysis. And it was in a single state, a single point of truth for all organizations that is updated automatically with new information. Our partner determined that even though they had tried using a traditional database first, it just didn't meet their needs. It wasn't nearly as cost effective. they were able to plug into a plug-and-play blockchain that features healthcare information that is also GDPR, HIPAA, and NIST compliant, and that met their needs so much more effectively than their traditional database did. Thank you.
I see. And since you talked about this and the data store on the chain, I will use the opportunity and ask also a question from the audience. You said that you store the data on the chain. Is this data encrypted? If so, why encrypted data on the chain versus other methodologies like anonymization? Is this sensible data? And thank you.
Yes, thank you. So yes, for this private permission blockchain, all data points are encrypted individually with their associated metadata. And that metadata includes all of the typical information about the timestamping that we see in other blockchains, but also includes that information about the complex ownership and granular consent capabilities that I mentioned. And with those, there can be layers of consent and layers of ownership that are part of that encryption, so only the authorized individuals can unencrypt that information. And then with the audit trails, only authorized individuals can even see the audit trails, can see what's permissioned, and can verify that there is appropriate data integrity. Please let me know if you would like additional information about that.
Sure. Let's move to Marco and Snika about the same subject. If you want, you can use the case that you mentioned, the eAPI.
Yeah.
Or another.
Let me start. When we started a couple of years ago, think about with the blockchain. For us, we had a very strong thinking about anti-counterfeiting. So how can we avoid or improve that? This is something which is sometimes people say $200 billion market, or 1 million people dying on counterfeited medicine. So we were looking into that. How can we solve that? And one thing to do that is controlling the supply chain. And how you bring everyone on the supply chain, how can you control that? Of course, technology-wise, you can use a central database, but that would be a huge risk. I mean, if this is hacked, all the informations are unveiled, and no one wants that. So there was the thinking coming, we need another system, and blockchain seems to fit on that from the idea, so that we can have track and trace of the medicine along the supply chain with all competitors in the market and the suppliers, without unveiling information to the wrong people, and also not having the danger of one big pot where all the nice data is, so the honeypot, so to avoid this situation. So that was kind of an idea when we started with Pharma Ledger, but quickly we realized there's much more behind it. We can do much more. And I think, and again, here we come back to the point, who controls the data? And we think the company should control the data, and not an intermediary in the middle who is controlling the data. So when we talk about supply chain, the data should be in control of the company, not of an intermediary who starts then to be the man in the middle and can control all the data. So that is what we wanted to avoid. Maybe maybe Seneca, you have a little bit more technical view on it and explain that from this angle. Sorry.
Yeah, you explained very well from the point of view of the companies, so to avoid internal attacks and all disintermediations that could reduce costs and other issues. And this is one side of data self-sovereignty, and the other side is the patient or the citizen's perspective. I think blockchains offer an opportunity to also remove these intermediaries and to give control, real control to patients and to citizens, to their data, and to hold these online activities that we leak all the day. So here is, I think, the huge opportunity. we see the view, we have the view that we could create, we have a technology that combines the web browsers with a digital wallet. So you keep your data and application inside of digital wallet. This is huge. You can do whatever you do now, but without leaking these big amounts of data. And it's not really possible without blockchain, because you get the trust and you avoid all sorts of security attacks by having blockchain technologies. So basically, this is my answer. It's in security, it's the biggest thing to help data self-sovereignty, the self-sovereignty in the security area.
See, I see, understand. All of you agree that there are clear benefits and tangible benefits. May I ask, and I will ask Ingrid to comment first, but everybody can comment as well. Since the benefits are so clear to us at least, why it does not scale in the market yet? Ingrid, you mentioned several blocking factors, let's say. But what would be, you believe, the step to see blockchain really scaling in the market?
Thank you for the question. I think in my experience, what I've seen globally is the interoperability and the lack of understanding of the benefits. So lack of digital literacy, I think, is probably the major one. It takes multiple meetings to even explain what the technology is. So it's very difficult for people within the decision-making realm to understand how it could be deployed. So I think those are the two that I've seen: digital literacy and then the difficulties with interoperability. The third one, if I may add, is the legal side, the accountability, liability, and difficulty with compliance that most data officers and compliance officers or the legal officers in our organizations highlight. So even if there is other interest, then once you get to the legal team or compliance team, it's a hurdle.
Okay. Is anybody else would like to comment on this?
Yeah, this is Marco from Pharma Ledger. For me, I think I agree on that. But what you have to build with blockchain is you have to build an ecosystem. So a blockchain alone at home is not much of value. So you have to build a full ecosystem. That means, first of all, the people have to understand the technology a little bit and all these kind of the benefits of blockchain. But then also you have to standardize, especially the data formats. But then you have to convince an ecosystem. I mean, I'm not talking about 2 or 3 or 4 companies. You have to convince hundreds, maybe thousands. And in Pharma Ledger, for example, when we start, we realize we have to involve regulatory bodies. We have to involve the hospitals. We have to involve so many. And I think that's the bigger thing, to build this ecosystem and to convince everyone to invest money in a new technology, which we can say, we think it could be a huge success for you, but hey, we don't know. And then why should a pharma company saying, okay, let's change our supply chain processes, which we have established over the last 20 years, to something completely new? And we not even know if the others also are using it. Why should we start? Maybe I wait till the others have started and we jump later on it. So building this ecosystem, and here the chicken egg problem comes in. If the infrastructure would be there, all would immediately jump on it. But at the beginning, everyone says, yeah, cool, but investment, what is about regulatory? Can we do it? Should we do it? And is it really? And so you have to create this ecosystem. I see that as one of the big hurdles.
Good, thank you.
I would also...
Please.
Okay, thank you. I would like to comment on the assertion that blockchain is not gaining traction in healthcare. First, we know that healthcare organizations have been late adopters of new technology, but even so, we're seeing some really promising progress in survey results of hospital organizations and of executives. So for example, in a survey of pharmaceutical executives, it was 70% stated that they plan to implement 1 or more blockchain projects this year, 2020. Not sure how much the COVID situation impacted that. But that was the goal, is that the majority were going to explore blockchain projects this year. And from surveys conducted by HIMSS, which is Health Information Technology Education and Advocacy Group, more than half of the hospitals stated that they were evaluating blockchain technologies. So even though they're slow adopters, I do believe that there's interest and that they are definitely looking at the evidence that's emerging and determining how well that fits into their strategic goals.
But I can concur that interest, there is a lot. Actual deployment on production, not so much. POCs, many. Let me move. We concluded the Q&A phase, but I will use the break for anyone that can stand. Let me move to another topic that is troubling a little bit, I think, the decision owners, the discussion between private and public blockchain. And it's a question that initiated from the audience as well. Can't open public blockchains be used for storing data in a privacy respecting manner? What about utilizing zero knowledge proofs or data lakes? Are there any initiatives exploring deployments on public blockchains that you know of in healthcare? I would add here, since this is the topic that we're interested in. Ingrid, do you have any insight?
Sure. So whenever possible, it should be private. However, that does not mean that everything has to be private, but we should always start for healthcare with the aim to decide what needs to be totally on a private chain and then what needs to be on a public domain. So having a dynamic and granular assessment and then being very careful as to what you put on the blockchain in the first place. So the answer to the question from the audience is, yes, you can put some information on the public one, but you have to be very careful what, and then same thing, ideally, you should start with the aim to use a private one if you can.
Not exactly in the healthcare, but in other industries, I've seen some solutions, at least in paper, that are using the public blockchain in order to, let's say, simply put a hash on the private information that is stored maybe on a private blockchain or another type of technical solution. To be frank, I've never seen something like that implemented in healthcare. I would imagine that it is very applicable to the healthcare as well. Have you seen something like that?
Projects, but not same thing like you mentioned before. They're only projects, but not large scale implementation. I think we see some inklings of that in other countries, but not yet. I've not seen it in Europe or in the United States, but I've seen concepts of it done in Arab Emirates and in India. So hopefully we will get to that. For precision medicine, if I may add, that's one project that I can very specifically say when you have precision medicine solutions on a global level, that's where I think I've seen the most proposals to have a combination of the concepts you mentioned. So I think we will see it over the next year or two, but like we mentioned, this year is the first one that we see a higher interest and a higher flurry of initiatives in this realm.
Okay, Wendy, I think the solution that you presented is on a private blockchain.
That's correct.
Correct. Have you ever had to dispute, I don't know, a client that says, since it's a private blockchain and you are managing it, then it's almost like having a central database managed by, I don't know, a single person?
No, none of our partners have taken the perspective that it's losing the primary features of blockchain. The private blockchains are designed to have a governance structure that the partner or the client determines in the best interest of their needs. And so their governance structure determines, which parties get to make the decisions, how is liability shared, how is risk shared and monitored. And we, even though we maintain the platform, all of our partners maintain the applications that sit on top, and they own their own data. The platform provider doesn't access the individual data and doesn't manage access permissions. So we created kind of a hard defining line as to what the partner, to maintain the governance structure that the partners have created and to maintain their sense of privacy and control.
Okay. One slightly different question to Marco and Sinika. I suppose you are aware of EBSI and what is Europe trying to do with deploying such tools to enable blockchain applications in the member states, but maybe not only. Are you looking forward to use EBSI for your for Pharma Ledger in the future?
Let me quickly start. I would like to go back to your previous questions regarding the storing of data in the blockchain, and then maybe Sinika can answer later. We have, in Pharma Ledger, we have the idea to say we do not store any data on the blockchain itself, whether it's public or private. Instead, we say we have a concept, we call that the OpenDSU data sharing units, where we anchor a little bit what you said with the hash link, or what also Ingrid mentioned, that we anchor the off-chain data in the blockchain so that we inherit the information, the properties from the blockchain integrity and this one to the data. But our primary goal is not to put data on the blockchain, several reasons, data privacy, a right to be forgotten, etc. and so forth. And so we want to implement that concept consequently in Pharma Ledger. And the first project we're doing is with EPI, Electronic Product Information, the leaflet, where we will do that. So yes, that is, I think it's not new I think a lot of people talk about it, but we have really built a concept around it to kind of standardize that. So that this process is kind of standardized, at least in the Pharma Ledger, but we hope, of course, beyond Pharma Ledger, that we use all this same approach of, we call it anchoring of the data in the blockchain. I mean, we call the concept OpenDSU, Open Data Sharing Units. Just, I wanted to mention that, yes, it's new, yes, it's not, and yes, it's not productive, absolutely. The goal is that we go with an MVP live by end of this year, and then of course we move on with that. So let's see if we are successful, but that is our idea. So I just wanted to mention that. Maybe Sinika, you can jump in with.
Yeah. So our approach also, I mentioned in my presentation that we also store code in this data sharing unit, and this is making us flexible in the sense that we can incorporate various technologies. I saw an answer now I don't see it anymore, about zero knowledge proof. Also, there are bits of discussion about identities. We try to generalize this off-chain to standardize the off-chain storage and off-chain computation, so we can incorporate all these new ideas and new let's say standards or projects that will emerge in the future. What we see that is missing is some sort of universal wallet that is capable to interact with blockchains in a uniform way, and so we can build and integrate all sorts of techniques that are useful for our use cases and for other. That would be my answer.
Maybe we forgot to answer the EBSI, the European Blockchain Service Infrastructure. With the concept we have with OpenDSU, for us, it doesn't matter which blockchain it is. It can be any blockchain. It depends on the use case and the governance body who says we are completely fine with that, or we need this, we want it completely private. It depends on that. So at the end, it doesn't matter for us. But to be honest, at the moment in Pharma Ledger, we haven't looked into the EBSI thing, but for us it would be interesting, because that would mean we have to avoid to build our own blockchain network. And as I said, it depends on the use cases. Maybe there are certain use cases they need high volume when you think about supply chain, or for the EPI we don't need high volume, so that could be something interesting. So we have to look into it. I think there was something, recent news about it, but cannot remember the details now. But certainly, as we are also a European funded project, we will look into that sooner or later. But the concept we have is technology neutral, means it can be used with any kind of blockchain technology or network.
Great.
I forgot to mention that at the beginning.
Thank you. So we managed to eat all the break, and the session is moving to the next panel now. Thank you very much for the interesting discussion. I'm sure that this was interesting for the audience as well, and I hope that I'm right. Please share in the chat your credentials if you can receive any specific questions, because there were some that were not answered, unfortunately. And thank you again. I'm passing the floor to Brian.
Hello. Hello. I'm wondering if actually everybody can see me, and can you hear me?
Yes, we can.
Yes, perfect. So I want to be very brief at the beginning. First, I'd like to introduce myself. My name is Brian Chalot. I'm at the University of Tübingen in Germany, but an American from my accent, you can tell. I just want to very quickly tell the audience again, not to forget the Q&A link at the bottom of your Zoom screen to actually submit questions. And hopefully we will either get to them during the presentations and or during the roundtable discussion. And with that, I would just like to introduce Dr. Wendy Charles to speak to us about one of the three big conceptual topics that we hope to touch on today. Mainly they are consent, which is incredibly important in the health IT space. Digital identity that allows us to enable sort of digital healthcare applications, as well as the entire topic of health data exchange or data exchange in general. So with that, I introduce and hand over to Wendy. Thank you.
Thank you for the introduction, Bryant. And now I will take control and share my screen and go into presentation mode. Okay. For those who didn't see the beginning of the first session, I am Chief Scientific Officer at BurstIQ, a blockchain company that specializes in healthcare and life sciences. And I also serve on several international committees that create standards, education, and advocacy for blockchain and healthcare. So I will be sharing my passion for use of blockchain for dynamic consent and the ethical considerations for data management and privacy. So first, it's valuable to start with a definition. While there are several accepted definitions, dynamic consent is often described as an approach to informed consent that enables ongoing engagement and communication among individuals and organizations, although typically between an individual and a researcher or an organization. Now, the component that makes consent dynamic is the individual autonomy and resulting changes in circumstances and perspectives. So therefore, the primary goal of dynamic consent is ongoing data sovereignty. So dynamic consent is becoming increasingly important in healthcare and life sciences as there have been shifts in our design and thinking about as we collect and aggregate more information for deeper analytics. So this list is just a sampling of data efforts that focus on improving healthcare by putting the patient at the center. And this often means aggregating and analyzing more information about patients, preferably with their permission and sense of control over time. Individuals could be presented with dynamic consent options in many ways. And these are just some examples where dynamic consent is currently employed in healthcare and life sciences research. The underlying premise is that patients are asked to choose who they would like to share their health information with and for what purposes and how they would like to be engaged in the activity. And of greatest importance for dynamic consent is that patients can also change their preferences at any time and for any reason to maintain that autonomous decision-making authority. So while there are software programs operating on traditional databases that can successfully enable an individual to change their consent preferences over time, blockchain is emerging as a technology that can enable dynamic consent in a more flexible and efficient manner with more complex features. So as you learned earlier today, smart contracts can be employed in blockchain to automate data sharing, alerts, payments, inventory, or really any data transfer in a more efficient way. And next, we're seeing blockchain to allow layers of individuals or organizations to have simultaneous control of how data are accessed, used, and shared. It can be a hospital, a doctor, a patient, all might be considered owners, where each can make decisions about data, but within the prescribed governance structure parameters. And next, blockchain facilitates granular consent, or some people call it fine-grained consent, where there are almost infinite choices about how information can be shared. And while current software programs with dynamic consent, a patient is presented with a prescribed list of choices. But with the blockchain applications that we're developing, a patient can share their entire medical record or just a single data point with any recipient or list of recipients indefinitely for a period of time or until the patient changes his or her mind. Next, blockchain by its very nature creates an audit trail of activity to preserve integrity and auditability of the process and can offer full transparency of the activities, including the option of letting the patient see who's accessed and used their information. And that has been in place for the country of Estonia for their health record system since 2016. And as the last example, but certainly not the last benefit of blockchain, blockchain uses cryptography for enhanced security of the data points to better enable privacy. Now, as blockchain is increasingly designed for dynamic consent, it's important to evaluate the ethics related to patient autonomy and dynamic consent. Now, these particular principles seem straightforward, somewhat obvious to me after having been an ethics review board manager for many years, but data administration can be very manual and burdensome, and patients can change their minds about inclusion in a research study or data repository, but the process of withdrawing is currently very effortful. And to withdraw, some organizations ask patients to write a letter and send it in postal mail. Some allow email as well, but even then an administrator has to go in and manually change the preferences, which is also very time intensive. And from an ethical perspective, it provides a lot more control for patients to be able to manage their own permissions and then for the changes to be automatically implemented. And when a patient makes their own changes, it's very clear that this is what the patient has intended, and there is no ambiguity about the patient choice. So overall, if there's patient visibility into the process and there's more transparency of use, there can be more trust in how their information is used. Now, when giving patients more choices and dynamic consent options, there still needs to be voluntary, autonomous, and informed decision-making. This diagram at left that was designed through modeling shows that while people make decisions that they may not actually understand the decisions that they're making. And therefore, it's important to ask, how can we ensure that dynamic consent is meaningful? What features should we consider for a successful patient-centered consent process? So in the following slides, I'll offer several factors that influence the ability for individuals or organizations to create meaningful dynamic consent. So the first group of considerations relates to an individual's ability to understand and navigate the technology and information. So as examples, not everyone has sufficient familiarity with computers or smartphones to navigate a website or is proficient in the language that the information is presented. And next, for healthcare and life sciences research, there are often medical or scientific terms that people don't understand. So for example, you can give someone a choice as to whether they want to participate in neurological research or endocrinology research, but would they understand what those categories of research involve and what types of research might be involved? And next, some choices might be straightforward, but many are so complicated that a person either needs a lengthy document to evaluate the information or needs a detailed explanation by a physician or a researcher to explain this information to them. And a classic example of that is genomic research. Very few people understand that when they agree to have their specimens used for genetic information, that they are not just consenting for their own information to be shared, but it also reveals information about their immediate family members. And you've seen in the press how some public DNA repositories have been used by genetic investigators in order to create genealogy trees and track down a family member who has committed a crime. So it's just an example of how complicated the choices can be and how people may not understand these concepts. As this last consideration, what should be done when a parent gives permission for the information of their child and that child reaches the age of majority in the jurisdiction in which they reside? Should that permission expire, the parent's permission expire? Should the administrator or the organization come to the child turned adult for their own permission? Or what happens when an adult who made the decisions loses decisional capacity due to illness or emergency? What options are in place for a representative to gain access? With some behavioral considerations, humans behave in unusual and unpredictable ways. And I've listed some of their behaviors here, and I will only talk about two of these. I'd first like to explain about the privacy paradox. The privacy paradox is the discrepancy between what people say about their interest in privacy and how they actually behave. And so typically a high percentage of individuals state that they highly value their online privacy and want their information to be controlled and respected, but then they may not exercise their options for privacy or engage in a private manner online. My last bullet point is about data and anonymization. And at this point, I'm not talking about privacy legislation, but the capabilities of artificial intelligence and future of quantum computing to connect multiple data sets and which can allow people to be re-identified. And in particular, there's a researcher at Harvard, her name is LaTanya Sweeney, who has devoted her career to show how data sets can be re-identified even using public information. But in healthcare, there's typically access to the reference data sets in the electronic health records, and the patient population may be smaller, increasing the possibility that individuals could be re-identified. It's just important that when we communicate these concepts to individuals that they understand that data anonymization is not of itself a foolproof method of protecting their identity. Thankfully, Dr. Ingrid will talk about digital identity in the next session. Going on to technological considerations, the concept of dynamic consent assumes that all patients would have access to computing devices such as smartphones and would have access to the internet where they live or work. But that isn't necessarily universal, especially among elderly individuals. And as we talked about earlier, smart contracts are not necessarily smart or contracts. And while computer code can automate features, it can also be faulty because it's programmed by a human. And we just shouldn't have complete confidence that the software will always perform as intended. Key management relates to usernames and passwords or private and public keys. And patients aren't very good at maintaining their access permissions on their own. And so it's just important to consider whether you implement a key wallet or have an administrator help people with their access. And the last component is need to design from the ground up how your technological solution is going to enable the technological, procedural, and administrative components necessary to comply with all regulations. As the last group of considerations, there are different perspectives in life sciences research. When it comes to the right to be forgotten, you're probably aware that there are specific exceptions to that for conducting research, such as the need to maintain sufficient population distribution to avoid selection bias, and also to maintain safety information of all participants instead of only those who stay in the study. Of course, I won't even go into the debate about the perceptions of data ownership or how data use and consent permissions are widely interpreted. But there definitely is concern that some researchers can engage in mission creep, and there's really no mechanism of oversight for data that have already been accessed and downloaded. And last, even when patients make a truly informed decision at the time that they provide consent, there are constant scientific advances that allow researchers to do more with data or specimens than anyone could imagine. And this is particularly true with genomic research. So among the many problems I faced with blockchain-based dynamic consent, I'm happy to provide details and examples during the panel discussion, but I'd like to draw attention to just a few concepts in this presentation. So first is, one of the first issues that I face has been mentioned by other panelists in the first session, is that there are lots of misunderstandings about blockchain in general. And the most individuals that I interact with now have heard of blockchain, but they either have a very narrow view or what they know is outdated, and sometimes it's just plain wrong. So it has been critically important to continue to educate individuals about what these specific features can offer. And many times, as Dr. Ingrid said, we don't even mention that it involves blockchain. And the other panelists have talked about public versus private chain capabilities. I'd also like to go into, for healthcare, there has been tremendous hype in the past about what blockchain could offer, and there hadn't been solid evidence for it yet. So a challenge that we face is that individuals are still skeptical about whether or not blockchain can deliver, and there haven't been as many large-scale implementations to show the amount of data that healthcare organizations are looking for. For cost, there isn't the type of expensive computational intensive mining for all blockchains. Those are typically for the public blockchains that involve the proof of work consensus. And private blockchains may have a different cost structure. They may not charge for transactions such as what's called gas for those who use the Ethereum blockchain. Blockchains that process healthcare information tend to choose privacy and consensus mechanisms that offer more control over their governance structure and therefore some of the cost. The last point I'd like to make, I'll just jump to the last one, is that for the projects that I have been involved with, organizations are asking us to design some things that have never been built before. And some of these organizations don't even know what questions to ask. And so we have to counsel them and about a new way of thinking about how data can be collected, how data can be managed and organized, how risk assessments are different in the way than they had thought of before. We often have to teach these organizations a new way of how to process their policies as well, and to communicate to their stakeholders. All of this is doable, but just requires everyone to gain education, exposure, and experience with blockchain to realize the potential. For this particular audience and those specifically who are legislators, what are some opportunities to advance the blockchain technologies in the EU? Specifically coming from a blockchain healthcare organization, we would just really benefit from your ongoing guidance about specific questions that come up frequently about how blockchain is best is utilized, and some legal interpretations. And some have already talked about the right to be forgotten. And while there are 4 to 5 different ways that have been published in the academic literature, the company that I work for example, offers 5 different ways clients or partners can choose for how they would like to address the right to be forgotten. And some of these are technological solutions, and it'd be just really helpful to gain clarity about whether, because they meet the spirit of the regulation, whether that still satisfies the intent or whether it needs to meet the letter of the regulation. And overall, we just encourage individuals to continue to be more educated and with blockchain capabilities. All right, thank you.
Great, thank you, Wendy. So I think what we will try to do is to save some of the questions that we got for the roundtable discussion. And I'm sure if Wendy had a few extra things to say, then we'll try to address those during the roundtable session as well. So in the interest of time and to give Ingrid, Dr. Ingrid Vassiliou-Feltes, her 15 minutes to speak with you, I would just like to introduce you to her and let her speak about digital identity. Thank you.
Thank you. If someone cannot see my screen, please let me know. For those attendees that did not attend the earlier session, just real quick, I serve a dual role in healthcare. I've had experience for 15 years in various compliance, research, quality, and safety roles. And then in the not-for-profit arena, I'm the Chief Ethics Officer for the Global Blockchain Association. So that allows me to interact with 90 chapters worldwide. So my views on this are just a conglomerate for all the perspectives shared with me by members globally. So this second section will focus on digital identity. And before we can even talk about digital identity, we have to define just very briefly what is identity. You have the classical human identity perspective, and that has a philosophical, law, societal, and cultural connotation. And then when we talk about digital identity, we refer to what is machine related or computer related or digitized, the way you'll see it defined. Just on this slide alone, we could have a conference. So in the interest of time, we'll move on. When we talk about further refining digital identity, it's described as information on an entity used by computer systems to represent an external agent. When we talk about entity, it can be a person, an organization, an application, or a device. And again, within the realm of this digital identity, you can have electronic signatures, seals, timestamps, registered delivery, website identification, authentication, and all these things need to be considered when we talk about digital identity. Another very important setup for our conversation is to think about identity domains. And again, if you take the philosophical perspective, you have a naturalist view versus a constructivist view. From a legal perspective, this is the one that causes the major hurdles globally when we talk about why we can't adopt blockchain at a higher rate, because there's so many elements in terms of your legal identity rights that need to be integrated with the digital identity that we're trying to build. And that's the personal integrity, privacy, freedom of thought, freedom of religion, freedom of expression, freedom to vote, property rights, intellectual rights. So it's never ending. When you start to try to harmonize the digital identity requirements with all these, that's where you start to have issues that cause resistance to adoption. And then of course, expressions of digital identity. And we'll talk a little bit about biometrics and certain other more creative ways that countries have tried to implement. And then categorizations of digital identity. What out of all the published resources, I thought it would be valuable to highlight two of them. Cameron in 2005, I think highlighted a very nice set of things that anybody that wishes to implement digital identity should think about and make sure they address. User control and consent, minimal disclosure for a constrained use, which is something we've addressed a lot earlier today, and I think we're going to talk a lot in our conversation. Justifiable parties for healthcare, that's crucial. Who needs to see what and how much and for which portion of the healthcare delivery journey. Directed identity, the pluralism of operators and technologies, like we talked earlier again about interoperability, and when you have to have healthcare exchanges, how do you define identity for each of these operators? And how do you define identity for the multiple devices? And how do you integrate all these? That's the secret sauce to success. Then of course, the human integration and the consistent experience across context, meaning how we express digital identity and the content of what's contained behind that digital identity amongst multiple organizations, systems, and for various elements within the healthcare delivery or healthcare research realm. The other one I wanted to highlight is that I think was very helpful when we tried to address the self-sovereign identity topic was Alan's publication in 2016. And I really like this one again to start thinking about when you develop policy or guidelines or start to talk about healthcare exchanges or building global healthcare systems. So there are 4 models of online identity highlighted by Alan: centralized identity, federated identity, user-centric identity, and self-sovereign identity. And during our conversations later, I think we'll highlight how each of these can be valuable and what are the pros and cons for healthcare specifically and building collaborative healthcare exchanges and systems. And then I also liked the way he conceptualized 10 key principles of the self-sovereign identity. And again, similar to the previous author, user centricity, control, access, transparency, longevity of the identity, which is related to what Dr. Charles highlighted in terms of the consent and being able to revoke it or revoke portions of it. Portability of your identity. And when we say portability, it's portability intra-healthcare and also amongst various industries. So which portion of your digital identity would serve for voting and for financial and for healthcare versus what has to be super restricted only to healthcare and or to certain elements within healthcare. And then of course, consent, minimize data disclosure and protection. So I think this is just a good start, a core for anybody that wishes to build on digital identity. And then I prepared a slide with hot topics overview that I think we all need to start thinking about. Definitely the major hurdle internationally, like I already alluded to, is the equivalent legal status as a traditional paper-based process. So when we build these digital identities, what out of all the digital identity elements is equivalent to a legal status and what does require correlation with a physical object, such as another paper-based identity versus what transactions or what portions within the healthcare delivery model can just be a completely anonymous digital identity that does not have to be linked to that physical legal object. And then of course, like we already mentioned, the self-sovereign concept, cross-border validity and reciprocity, not only for the European Union, which is our focus today, but also globally, because you might have entities where portions of the data is shared globally, And although the originator of the transaction might be in the European Union. So I think this has to be considered because particularly from a pharma perspective or medical device or medical equipment perspective, it's not as simple as just saying you're in one continent or in one type of confined organization. You need to think globally. And then privacy, custody, and delegation of digital identity, security, obviously, and interoperability or data exchanges, as well as the one that I really care about tremendously is technical architecture, design, and standards. And then I would love to propose that we should, particularly for healthcare, talk about application of digital twins as a priority, because that could be one of the solutions that solves all our pain points. And last but not least, to set us up for a nice discussion, if I had to select out of all the issues mentioned, something that is really important, digital twins. So I would like to propose that we have a discussion on how a healthcare digital twin could maybe address some of the issues, interoperability amongst healthcare systems, as well as within the healthcare ecosystem. And then of course, Internet of Health and Internet of Medicine. We can't talk about digitizing identity without understanding that it all has to live in a global internet ecosystem as well. So maybe we need to start thinking about having a more refined and more specialized Internet of Health, as opposed to put our healthcare data in the global Internet of everything. So I tried to keep within the minutes allotted, but I'm hoping that we can have a great interactive conversation. Thank you for the opportunity.
Great, thank you. Thank you, Ingrid. So again, I think we will try to hold the questions until after, and we have lots and lots to talk about. I would like to introduce now Mike Davey, who will speak about the larger topic of data exchange between systems and institutions. And then hopefully we are exactly on time now. Perfect. So Mike.
Perfect. Let me just get the presentation up here. Perfect. So for this section, we're going to talk more about the data exchange aspect of data sharing. So to give some background, back in 2014, we launched a company called DataStreamX. It was a data marketplace with the intention to help telcos monetize their vast amounts of data. Within a couple of years, we had some of the biggest companies in the world, from telcos to financial data, personal location data being used. We were transacting billions of records per month. By 2016, we started dealing with location, mobile data, and that's when we started to see a lot of the issues when you're dealing with these large open scale, large scale data marketplaces. So what happened in 2016-17, we really started focusing on location data, which is mobile data, which is a pretty hot topic these days when it comes to data privacy. And as we started transacting with more and more publishers and more buyers of this data, we were getting into the hundreds of millions of individuals which we had data on. The first thing that we noticed was the supply chain was very, very murky. There's cross-contamination between organizations where you see data coming from other organizations who said they had all the data rights to this. They said, this is all our data, but we could see it coming from, at one point we saw 5 organizations all transacting the exact same data feeds. And so when it comes to this murky type of industry, when there's no transparency on the supply chain, it allows for a lot of bad actors to get into. We also saw, especially in 2017, as we approached 2018, regulations coming into effect to start trying to clean this up, GDPR being mainly one of them in Europe. But also we see CCPA happening in the US, and we see actually Brazil and other countries all implementing these GDPR-style regulations when it comes to personal data. The last thing is that we see that there's a lot of disparate sources of data. When you think of when companies are trying to solve issues, they can't always go what we call the atomic data producer, the original producer of the data, that it's very difficult to start aggregating these things together. And in the medical, for medical records, for example, if you're trying to collect, hundreds of millions of records from people to do large scale studies, you would have to go to like other individual doctors or individual countries where all these things are all disparate. And so for us, the location industry, for us, we saw this. We saw that everything, the data was everywhere. There was not one source of data. There's not one powerhouse you can go to get all your data needs. So the buyers and the users of this data were stuck going to multiple sources to be able to get this type of data. So we were looking in 2017 for a solution to this problem. We wanted something that had provenance, authenticity, a system where we could build trust into it while doing it in a secure manner and building integrity into this ecosystem. So location data, we call it highly sensitive data because it does have the data of where people move in the real world. And much like healthcare, this data must be safeguarded. So this is when we asked, or our VC said, hey, what about blockchain, and have you thought about this? And our engineering staff went and started looking at blockchain. So what I'm going to share now is just some of the boots on the ground problems that we faced while we were looking at blockchain as a solution to this problem. Well, the first thing in question always comes on: do you really need a blockchain? The technology is slow, the speed is slow, it's difficult to work with. There's a small engineering pool in the world that we can actually develop on this well. And what we see is the only really value it brings is when people don't trust each other. Because when you look at any technology, anything that blockchain solves on the technology front, you can probably pick a centralized solution that will outperform it. There's not really anything when it comes to blockchain that a centralized solution can't do better. We're still not at that yet. But the one thing that we did notice is that what it was really good for is if people don't trust each other. Our next problem was, and I think a couple other presentations alluded to this earlier, do enterprises care enough to make the hassle worth the investment? Whenever you're looking at a solution, does all the negative aspects make it better? Are they offset by what this can do, which can't be done already? We mentioned earlier, if people are using Ethereum or any of the solutions that have these gas fees and cryptocurrencies, this is a big no-no. A lot of enterprises aren't allowed to work with cryptocurrencies. So how are you going to power these type of networks when they have a gas or some type of cryptocurrency that powers it? Heavy code integrations, clunky interfaces. Blockchain's not easy to work with. There's much better technologies out there, and the interfaces, if you've ever tried to just use public chains, that the interfaces are getting better, but still they're extremely clunky when you're trying to do advanced solutions with it. Third problem here is, how do you distribute when it's not meant for public? I know you guys talk about private and public chains here. And the truth is, like, we're an enterprise where we're B2B. And so being a B2B company, no one really wants to run your nodes. And the question is, do you even want them to? The power of blockchain is when you distribute the nodes. If one person is controlling them all, you might as well just use a database because if you control the nodes, you're able to roll back things and you can manipulate any blockchain. So the power comes when you actually do some form of distribution. And so doing a public distribution is not really worth it. Do you want to expose yourself to the attacks? And if you're not going to distribute publicly, why are you doing this and who are you going to distribute it to? So we're asking ourselves all these questions on why are we actually going to put up with all this? Why is this actually worth it for us? And for us, it came down to the number one thing is that we operate in a system where all parties don't inherently trust each other. So when you look at location data, personal data that comes from mobile devices, the people who are providing it, the end users, the citizens, that they their data is being used in these applications, and they don't trust big corporations with them. Regulators don't trust big corporations to actually do the right thing. And even without those two players, businesses don't trust each other because they're always at each other on, is this data real? Where does it actually come from? Can I actually see the supply chain? And for years, this private data coming from mobile devices was such a murky industry that no one knew where this data was actually coming from. So for us, we did deploy the solution. So how do we get around it? Well, the first thing is that we don't use real-time asynchronous, we use non-real-time asynchronous operations. That's real-time systems, high-speed systems, they don't quite work. There's not really a great blockchain solution for that. So you have to watch on how you code it. We've already talked about not putting data on the blockchain. I didn't include in this presentation, but obviously we deal with billions of records a day, over 5 billion records a day. This type of information doesn't go on, doesn't actually go on the chain itself. So what we did is we minimize the operations that are on chain. We just ensure that events are logged opposed to actual data itself. And regarding the small engineering pool, you have to skill up. We had a 5-person team. All 5 of them became blockchain engineers. That for us, we just did this all internally and increased the knowledge within our team. Do enterprises care enough to make the hassle worth it? They still don't. Our enterprises pay in fiat, and they get paid in fiat. They have no idea there's a gas system that powers everything behind it. We have API backends that power all of our front end solutions. So we just basically had to build everything on top. So I think Ingrid mentioned earlier that you don't show the enterprise the blockchain aspect of it. Everything's hidden inside a nice interface. So now how do you distribute? Well, we already talked it here. We use a proof of authority, private chains. We mix a public chain for what we call anchoring. So we can't roll back our own private chain, but we use our own private chain to facilitate all the transactions. If you do follow cryptocurrency these days, or Ethereum these days, it's once again clogged. So anybody on a public chain really can't use it. We keep nodes protected, so everything is behind closed walls, and then also that the nodes are controlled by us. And in the future, we'll distribute these to industry players. As an enterprise B2B company, we never see it going off to like public that we're just going to say anybody can download a node. Businesses don't want that. There's no value in the system for us to do that. So on here, I'm just going to flip through and show you guys what we actually deployed. And so our platform, it basically takes into everything that we already discussed there. It has a very easy to use interface. People log in like they would any other portal. Now I'm going to focus, before I go on that, there's 5 solutions that we have currently. One is data stamping and verification. So when data comes into our network, we can hash it, we put on the chain so we can prove that this was a state of data when we received it. The next is a data smart contracts that monitors payments between organizations. So we can actually see, okay, this company bought it from these 5 people. So you can actually start seeing, and the events are logged. So whenever there's data that's acquired, then that chain is there. We're releasing right now a privacy and privacy and compliance module, which allows us to track consent. And then lastly, when data producers, individuals, we're launching an app where they can actually submit data in the location space, like point of interest data for us, and they get paid and rewarded by providing data into the network. So I'm gonna go into a couple of things on the CMP here quickly to give you, so we're talking on the topic of consent, right? So when people give, so in an app, our data comes from apps. They come from your weather app, your whatever app, navigation app that you have. And when somebody logs into that app, they see this privacy and consent screen. This was developed with IAB TCF2 framework here. And what this does is that when the user comes in, they accept it or they can customize their options. They can see all the purposes that are set up. That what is this data going to be used for? And then next, they can actually see which partners are going to use it. So they can actually select which companies they want to use. So we have both IAB, which is the industry body in the marketing part of the world, marketing industry. and the ad tech industry, and then we have non-IAB vendors. So anybody who uses Zap can put in their own vendors. So if all of a sudden it's to a university or some part of some study, that we can include in there, and the user has the rights to toggle between every single company, and so we know which can get access to that data and which can't. And then if they dive into it, they can see what is the purposes. So for every single company, we can see what are they going to do with this data. And the user has the right to go in and say yes or no on a per company and per use case basis. All these events are logged on the blockchain, but it doesn't go straight into it. So any event that comes from the web and mobile has to go through a few stages, it queues, and then it admits it to the blockchain. But these things are stored on the chain and off the chain, meaning that we have to first put it off chain and then we put it on chain, so we have proof of consent. So if a regulator comes in, we can say, okay, user 153 at this time said yes to these companies, and there's a proof, immutable proof on that. Now we go to the user control. You're talking about dynamic consent. We have a separate app that anybody can go in, and as well as opt out, say do not sell my data. They can request access to see what data we have. We can the right to be forgotten. They can do this delete request. So when this delete request happens, what they do is that they can now send that request through, and we actually then would disperse that request to all the parties involved. And the sake of time, I'm just go through a couple last things here. But the idea is that people have control. Publishers or companies that work with, they're able to set the control mechanisms easily in a nice web interface that shows them exactly how what their users are going to see and what the users are consenting to. And so all this is just, no one knows that there's blockchain running in this. It's just a nice user interface to ensure compliance. And lastly here, the buyer. So see if you're a buyer, the end user of the data, you can actually see the supply chain. You can see where this data came from, who was the original source of the data, and then where this data came from to come to you. And this is very important for transparency across industries now, because people don't want to be using personal data, be it health data or be it your mobile data, any PII data, any sensitive data, that everybody wants to know where it's coming from. And so for us, we're trying to put transparency into our industry, which is location industry. But at the same thing with healthcare, we can see the same lessons can be applied. And with that, thank you very much. I'll hand it back to you, Brian.
Great. Thank you very much, Mike. So I just wanted, first of all, to thank all of the presenters for these very big conceptual topics that they actually covered. And I just wanted to start, first of all, by introducing myself, which I already did. I'm at the University of Tübingen. I'm a surgeon, and an aspiring bioinformatician, and I work in the space of personalized medicine quite a bit. I'm just going to put up a slide. Great. I think everybody can see that. So I was really very pleased to participate in this workshop, simply because, honestly, many of the challenges that we actually that we have to deal with in our attempts to build personalized medical applications and to cooperate and collaborate with other institutions that we have to use their data without knowing what their data is, are some of the very same issues that Ingrid, Wendy, and Mike have actually covered right now. So I was really quite pleased to do that. Let me move to the next slide. So I want to start first with an example of kind of the things that we are dealing with, and then with a definition that hopefully will open up a bit of a debate. So as I noted before, I'm working in the German environment, which has very specific rules and require fairly sophisticated engineered solutions so that we can remain compliant when it comes to patient privacy, as well as patient rights. So here I have an example that is actually was originally published by Kuo from the University of California, San Diego. And what they find is the same situation that we are in, where we want to perform analyses on a small number of patients. However, that n equals 2 is inadequate to come to any reasonable solution or conclusion about the data that we have. So we are often in the position where we have to collaborate with other large institutions that may have 2, 3, 5 patients so that we can build up an N of 100 or 1,000 so that we can make reasonable conclusions about the data that we have. However, in Germany, one of the approaches that we're taking is completely abandoning the approach of sharing the data in its raw form. However, we are trying to use algorithms in terms of predictive modeling, or what other people call machine learning, that we can send out to individual institutions. The data at the host institution is analyzed on site, a partial model is built, and then that is handed off to the next institution to continue the predictive modeling. So you can see that this already sort of brings up a few things. Number one, an institution is hosting the patient data. Secondly, before the institution can make that data available to the algorithm that is visiting all of these separate institutions, they need to be able to be certain that there is a consent for that patient. And then the second thing is that each patient somehow needs to be identified. And it is very clearly possible that a patient may have visited multiple institutions. So there needs to be a way to de-identify the patient without knowing who they are. And then finally, you see that all of this information needs to be exchanged, at least in this model, how it is shown here, between at least 4 different machines or institutions or entities in this particular network. So interestingly enough, this is what Qualls published back in 2014, I believe. In 2016, they presented at what was actually the first NIST conference on healthcare and blockchain, sort of a proposal to implement this on a blockchain. And for them, they chose one particular aspect of this, and that was to provide the communications infrastructure between the institutions, and also what they call a new sort of consensus protocol, proof of information, which allowed you to order which institution was permitted to update the model next. In all actuality, it's a little bit more like a smart contract kind of system, where they could achieve consensus between the institutions without the need for what is there listed as the Global Explorer server, so that they could work among themselves to actually perform this online machine learning on data that is vertically distributed across multiple institutions without the need for a central server or a central entity. So I think this actually offers us a very good framework to think about how blockchains can actually be used. In their proposal, which I don't think they actually implemented, but it was presented at that conference, they were able to, in theory, eliminate the global Explorer server. And they developed a method or protocol where all of these servers could work along each other by themselves and coordinate all of the actions by themselves. So that, I thought, was one of the things that data exchange was how their proposal was addressing some of the data exchange. Who sends what, where, which partial model goes to which person or which computer. Obviously, the identity of the patients, they need a way to deduplicate data or patient data that is present at multiple institutions. And of course, consent. Each institution needs to make sure that they have a consent available for that record before they actually pass it on and make it available to their particular blockchain network. So what they've actually done is they've only taken care of the communications infrastructure and the coordination. And we have to think about some of the other situations. So this is what I call a collaborative sort of healthcare system. And I just wanted to leave that as an example. So the definition that I'm going to leave with us for the discussion is the following. So I was very pleased. Well, let me just say that I think whenever we think about blockchains today, sometimes I find that the wording and the nomenclature around blockchains is really a little bit confused. And so I really wanted to establish a definition, and I'm sure that there will be some debate, I hope, from the participants and the other presenters about what it actually means. So we've seen several different descriptions so far. One where bulk data is on the blockchain, and we've seen a system where bulk data is avoided and as much information can be collapsed into the lowest or the smallest amount of data to preserve sort of performance. So I tend to think more and more that blockchain is a difficult word to use, so I use the word sophisticated ledgers. I tend to try to avoid the purely structural definitions of blockchains, and I'm trying here to seed our conversation with a more functional definition of the blockchain. So I'm just going to try now to begin the conversation. And I think Wendy and I have spoken about this a little bit already, yeah. And I'm sure that I hope that the other presenters feel welcome to chime in as well. But why don't we start with Wendy? And let me ask you, as far as the way we talk about blockchains and how we define them, what are the particular distinctions that we need to start making as a community, right? With regard to the structural side or the functional side, what their capabilities are, and what are the primary blockchain capabilities in your case, for example, that you rely on to deliver the solution that you, that Burst IQ has created.
Mm-hmm. You know, this is such a pertinent question. When I served on the HIMSS blockchain task force, we were a group of international experts in blockchain. And one day, amongst ourselves, we had a 40-minute debate about the definition of blockchain. So there isn't clear consensus yet. What we are seeing is that even though distributed ledger technologies and distributed networks are functionally different than the early stage blockchains that were based for cryptocurrency, we're seeing the terminology evolve, and that the term blockchain is becoming to encompass distributed ledger technologies just by virtue of much more exposure and familiarity. So distributed ledger technologies are now being referred to as blockchains as well. You know, they ultimately have some similar features in the way that encryption, distribution, smart contracts, ledgers are all being used and can be used for unique purposes that serve a need. I can continue going unless you want me to
so I can. So let me jump to Mike at this point. So I think I saw in your presentation that you were using ERC20 tokens in your solutions. Is that correct?
Yes, we do. We have a 2-token type model with private and public chain put together.
Yeah. So just for the audience, ERC20 tokens are based on the Ethereum blockchain, which is absolutely public blockchain, but you were also the solution that tried to minimize as much bulk data that was being put on the blockchain, probably for privacy concerns or competitive concerns between the institutions or the participants on your network. I don't know if you can speak a little bit about that and how you came to the decision to, let's say, anchor your data in a truly purist, public, robust blockchain that could probably deliver immutability, right? While matching that or marrying it to a private sort of facet of your solution.
Yeah, so like I mentioned with blockchain and this distributed ledger, if you're not distributing the ledger, then really what's the purpose of a blockchain, right? That there's just so many other technologies that would perform better. But with that inherent, we don't trust the parties, but you're going to control the nodes. Well, the problem is, how do you ensure that you don't roll back the nodes, or even a consortium? You have a consortium of 5 actors that are each controlling a single node that produces the blocks. If all of a sudden all 5 decide to team up, or 3 out of the 5 that gang up and roll things back, there could be issues, right? So what we saw to offset that is that we anchor in a block at certain intervals. And so what happens is there's a public record of what our block hash was in a public chain that we can't roll back. So the furthest we could ever roll back our private chain is to the last time we anchored on the Ethereum network. So what happens is actually no information on the public network. All the smart contracts, everything's processed in our private chain, but we just have that single hash that we anchor in a smart contract on the Ethereum network, that if anybody comes to our thing, we say they can actually see, oh, wait a second, here's on the Ethereum network. Let's just prove that these guys didn't shut down the chain and make a new one, reverse all the smart contracts and change things, change what the data should be on there. And so it's an ability for us to get all the benefits of a private chain, private network, while still getting that immutability in a public chain that we don't pay for. Meaning we don't pay for all the nodes in the Ethereum network.
So I'm going to ask you some more questions later about that, but let me ask you and Ingrid one question. For me, one of the essential features or one of the essential promises of blockchains that they're supposed to be able to deliver is this digital notary capability and the ability to create sort of bulletproof audit trails, right? And I was wondering if you view it that way as well. And for the different applications, we have identity, consent, and things. They're all of these particular applications or needs need to be able to sort of convincingly demonstrate that this happened at this time by who, and this was the state before and this was the state after. So do you actually agree with that probably one of the most essential features of a blockchain is the ability to provide for digital notary that we've never had the capability of doing before?
I can jump in. So I agree. As an ex-compliance officer, I think that's the one that I always try to explain. And like Wendy, we try to always make sure we correct those that think that it's immutable. Nothing is really immutable perfect, but it's definitely auditable. And certainly compared to the traditional methods of doing audits post-factum or post-event, or certainly not real time, I think that is a unique feature that personally, particularly for healthcare, not only healthcare delivery, but also for research institutions, it's extremely helpful. And that's the one that actually convinces many organizations to use it compared to other technologies.
So you find that this this particular feature is actually one of the most, or one of the best, let's say, the most persuasive points for, let's say, the chief information officer, chief legal officer, chief, etc., C-suite person, about persuading them to at least consider blockchains for their particular need.
In my experience, it has been very helpful, and I'm not sure if it's because they truly understand the value or because maybe they don't have many other alternatives. I think when it's only about all the other features, in their mind at least, there's much more education that we need to do to see the benefits, but this one is very easy for them to grasp. And it certainly makes a very good also point from an overhead perspective and the return on investment. They can quickly see the benefit of having a fully automated audit function versus a retroactive, delayed, very cumbersome human way to do audits.
If I can
excellent.
weigh in on,
Wendy,
on that
Wendy,
question
do you have
too,
any
sure.
comments?
Yeah, I just wanted to point out that for life sciences research that's subject to FDA regulations or Annex 11 regulations in the EU, that data have already been required to have an audit trail and validation since, for the FDA regulation 21 CFR Part 11 since 1997. And so there has been attestation, there has been individual traceability of actions and audit log for a long time. So for life sciences research, blockchain doesn't add value in that regard. But the big sale that I have to life sciences organizations is how blockchain can empower data in ways that they have not been able to do with traditional database systems. For example, the power of crowdsourcing, exponential learning, federated learning. For example, the work that I do is on creating longitudinal profiles of individuals based on multiple sources of data that we can bring together in a meaningful way, very efficiently using blockchain. So I think that the primary value, it depends on which audience you are targeting and what their particular needs and interests are.
So may I counter or rebut?
Yep. Yeah.
So yeah, so this is supposed to be a debate, and the audience, if you have questions, feel free to chime in on the Q&As, okay? So I would say, or I would counter that what is different is that if we are able to encode things like identity, consent, individual data elements in a digital form, we now have the opportunity to automate that. So a lot of the audit trails that I've seen in the hospitals and in clinical trials usually are in the nurse's cabinet, the study nurse's cabinet under the desk, ready for the regulator to call them and answer the phone, open the drawer, open the file, and answer the question. Or large documents go over. I know in the last few years that things have become a little bit, have been digitized to a certain degree, but there's still a lot of effort that goes into it. And whenever you have the ability to clearly identify a document and to not really, I don't want to say transact, but to automate the movement of that information to know what it is about in a digital form, you have the opportunity to automate that. So instead of for example, the approval process for a drug taking 3 months because they have to go through the audit trail, that may actually be available in real time, all the time during the study or after the study, and also would probably be able to be performed very quickly rather than receiving a full file or a file cabinet and then having people go through it individually.
There is frequently confusion between digitization and electronic records and electronic signatures. And what you are describing are definite benefits of digitization. Many regulatory agencies require electronic submission of records to submit for their pre-market approval or their new drug application, and those must meet specific standards for data nomenclature for the organization. And if stored in electronic format, it must meet the regulatory requirements for electronic records and electronic signatures, which includes an audit trail by default. So I just want to make sure that we are comparing apples to apples and recognizing where is the current state of life sciences research and submission to regulatory agencies.
Yeah. So I totally agree with you. And a lot of this has become electronic in the past, in the recent past. But what I still find very interesting is this, this particular digital notary aspect, where we know the sequence in which events occurred. We know the sequence in which, at the time at which, all events were reported, et cetera, et cetera. So let's try, unless one of the other presenters has something to add, let me bounce back to Mike. You did mention as one of the boots on the ground's problems of in implementing these solutions was that institutions find it burdensome to deal with cryptocurrencies, right? So I had a question. Do you actually use ERC20 tokens to provide your timestamping and your checks, you know?
Yep.
So to what degree? And I assume that you have to pay fees to do that notary.
Yep. Yes.
Yeah.
Yep.
To what degree does that interfere with your ability to run your application efficiently? Number one. Number two, how do you deal with, and I assume these are small amounts, but how do you deal with the exchange rate volatility that you may see or that you're not protected from?
Yeah.
What happens if you tell your client that Ethereum fees have gone up by 1,000 and the price of Ethereum has also gone up by 1,000, so times 10 to the 6, and now you tell them that we now need to raise your, your service fees?
Yeah. So I'll deal with the second question first. It'll be the short one, is that our clients don't see any of that. It's a cost to us. Our accounting books are awful. We operate in Singapore. So we're a Singapore-based organization with offices around the world, but we do all of our main books are in Singapore, where cryptocurrency is an asset. And so it's held on your balance sheet. And with that, makes it every month the currency fluctuations go up. So it makes our books look awful, to be honest, and that's sort of what we have to live with. And then on the client side, they just don't see any of that. It's an expense to us. Going to your first question though, regarding institutions and using cryptocurrency, and I'd even put like cryptocurrency is definitely quite difficult, but even blockchain as well, is that blockchain, this entire presentations, all the presentations we're seeing is we're trying to cram regulation, we're trying to solve solutions to regulation, which in my view is actually going in some of the wrong direction. That data sharing, data exchanges, a lot of regulation is talking about how we shouldn't be sharing data. And it made me actually sad when, Brian, when you're showing like the 3 institutions, you have N2 and then N3 in different institutions, and they can't share data to actually solve problems. Just means people are dying because regulation is saying, oh, these institutes can't share data. But why can't we share the data? What is wrong with it? Like, what is the true root of the problem? And that's a misuse of data. And how do people use the data? What are they doing wrong with it? What can happen if people misuse it? That's where regulation should focus on. So I hope anybody in the audience who's actually working on the regulation side has to start looking at that. Sharing data is not the problem. Sharing data is going to solve a lot of problems in a lot of industries. Healthcare is the number one. That we can save a lot of lives by sharing health data, making research faster, identifying problems as they spread globally. And us creating using blockchain to try to appease to these regulations and creating like a zero sum, like you send the algorithm to here. This is somewhat, if you really think about it, and to your point, like what those institutions, our clients think, it's ridiculous. We're doing all these really out there ideas trying to just make regulation work. So on our view is always regulation should protect citizens, protect people, and ensure the bad actors get punished, but it should not stop sharing, and it should not stop the sharing of data. And so maybe one thing like what Ingrid just mentioned was audibility, like the immutability or audibility. Maybe if blockchain solves the who used this data, what happened at each time, where did this data go, and we can prove where it went to all the good actors, and if it went to a bad actor, we have this trail. Maybe regulation will start lifting, and allowing institutions just to get straight access to N1 to N100 coming from 7 different institutions. Where the problem, so you don't have to do that weird thing of setting an algorithm, which is not going to train properly, which is you're trying to put a Band-Aid onto a solution that really doesn't need to be done. If you put all the data into one place, it's going to be much more efficient. And so hopefully that's where blockchain can do. It can build trust in these data exchange situations, make it audible for people, and then regulations can sort of ease up and not stop the sharing of data. You know, people, especially in the healthcare industry, can solve many great problems with data.
So that's a great comment. So I want to bounce to Ingrid because you provoked 2 more questions for me, right? So so digital identity is so interrelated to both the data exchange side, both on the machine and the human side, because I'm sure that the regulators come to Mike and ask what happened here, what happened as far as, do you have the right to hold the data? And secondly, are you actually properly transmitting the identities so that you actually come to proper conclusions, I'm sure. So the necessity and the importance of digital identity is very clear to, I think, to me, and I think to most people. So I'm going to ask Ingrid, from the sort of regulatory perspective to a certain degree, so where can digital identity actually harm the individual or society at large? And are there any potential remedies that can protect us from those evil things happening with data, sort of in the way that Mike was alluding?
Well, that's a
And I believe Ingrid needs to go very quickly.
Yes,
So,
yeah, I will try, but I can
so-
answer this and then I'll drop off. But it's a very important aspect, and definitely I think we touched on it today at various points. But that's why we mentioned we prefer a private ledger as opposed to a public, to having unique cybersecurity features for healthcare. I think is going to be important too. Deciding what we want to put on the blockchain, like we mentioned several times today, is crucial. Not everything in healthcare needs to go there, but yes, in terms of potential consequences, people can, like in every other industry, take your identity and use it for the wrong reasons. So I think everything we mentioned today, if you do it proactively and have the proper consensus amongst the participants as to what belongs actually on the chain or not, then you can safeguard some of those potential negative consequences. But yes, people could take your identity for financial reasons, for voting reasons, for legal reasons, not to mention discrimination or many other issues that can occur. But overall, I think if some of the elements we try to address today in terms of standards, and specifically for digital identity, it's proofing, validation, authentication, and thinking about all the elements that happen in the process can safeguard against these things. Nothing in this world is totally hack proof. I mean, that's a utopia to think about that. I think what we try to emphasize is that having a proactive, mindful, thoughtful approach and trying to put out there only the minimal required information that's helpful towards global population health, and with a proper dynamic informed consent that we talked about, that's all we're trying to emphasize. And particularly from a regulatory perspective, that's what we try to aim for. Thank you.
Excellent. So I want to thank you for your participation, Ingrid. I know that you have to go, so I want to make it as easy for you to slip away. All right.
Thank you.
If it's okay with you two to continue for another question or two, then I would have another question.
Sure.
2 questions. So I'm just going to throw it out there. I'm not going to assign it to any one individual. So we've talked about very specifically healthcare systems, right? Except for Mike, that has come from a broader sort of different solution. So one question I have is that, do we really need to have specific healthcare systems, that use these blockchains for identity, for consent, for data exchange? Or should we be building more universal systems, that can be used as building blocks, so that, for example, a researcher might use the identity system at the same time that, for example, the insurance company in a privacy preserving manner might continue to use the insurance system. I mean, the identity system to identify which patient has come into the hospital today, who do they need to pay out to, what's the identity of that person's or that hospital's bank account, et cetera, et cetera. So I'm just going to throw that out there and see what you guys have to say.
You know, because I've worked in healthcare, regulatory compliance, and now blockchain for healthcare, my views are shaped by my experience. Healthcare and life sciences research is a highly regulated environment, not just to prevent bad actors, but because we want to demonstrate respect for individuals and provide as many ethical protections as is reasonably possible for the most sensitive information people have, which is their healthcare information. I don't know that we necessarily need separate systems for healthcare, life sciences, or other industries, but we do need to be mindful that systems that we create must adhere to the minimal regulations that apply to that jurisdiction, typically privacy regulations, and that we want to design our systems to be maximally respectful of the nature of data being stored and the individuals represented in those data sets so that they are not caused harm by any of the actions we take, no matter how well intentioned. So I'll stop right there.
Great, perfect. Mike, do you have any comments?
Yeah, just say when you look at the major thing in healthcare, it's the data itself, which is off chain, and it doesn't really. There's the way that data is stored in healthcare is a lot more cumbersome, a lot more expensive. So it really comes a cost benefit analysis, right? Like if all data in the world was stored the same way that healthcare data was going to be stored, then we wouldn't be able to even run the internet. Like you couldn't have a web page with the same level of security that you would have.
We'd still be in the dark ages.
Yeah, exactly. So when you look at like, that's the most sensitive part of it. But everything else, like when you look at consent, so consent of usage of data, that would be same like what Ingrid just mentioned, like voter rights. So I'd probably put this as the same as healthcare, right? Or location data, which we're in, is the same as healthcare. It's sensitive data. You don't want somebody to take control of any of those data sets. So I would say that when you look at like consent and right to access and the audit trails, all of that can be universal. So I would say those top layer things should be across all types of say personal data and identity.
Yeah, I think that's where I fall as well. I think those top level, high level sort of core capabilities, core functionalities are the more core and the more fundamental they are. Those are the ones that we should be thinking about, maybe potentially having universal solutions across industries and across geographies and jurisdictions, if at all possible. That's a big dream, but that would certainly make life a little bit easier for, it would take us out of the dark ages. Great, so I'm going to end with another question unless somebody else has a comment to make. And then I think we're going to wrap up. Unless I think that's right. So I find that, you know, as we implement things or as we write laws, we're often confronted with this dichotomy or choice between two options, between the individual rights and privacy versus the potential greater societal good to everyone or to the entire system. And, you know, I kind of wonder what you guys think about which approach should we take. And mind you, I'm the one that created these approaches, right? So it may not be true. So you can add a third or a fourth. So I think either we're forced to choose with, we're going to make a top-down, almost paternalistic decision. This is good for you, right? So you're going to do it, you know, from the legal side or the regulatory side, versus, you know, from us, let's say the bottom up, the ones that are trying to build these things and implement them, should we be making a very large effort to define a certain set of promises that we can make, and then either persuade or let the general population be convinced that we are able in a privacy preserving manner, in a manner that will not harm them, identify them in a way, obtain and document their consent, allow us to use their information to do these collaborative sort of efforts, and that's that. So do we try to demonstrate to everybody that we have these capabilities and we can deliver them and they're not going to be harmful? Or do we just say, honestly, the greater good in the balance of, in the greater equation, you know what, it's okay. We should be just plain sharing the data raw, because honestly, there's too much to gain if we don't.
I'm almost screaming inside. I have a very strong reaction to that.
So
on which side though?
So what have I said that is so disturbing? So that would be very informative.
Yes. After, again, based on my career and having served in ethics roles and for human research protections, I err very strongly on the side of respect for persons, respect for their information, and protections of inadvertent release of their information. The nature of human subject research, clinical research, is about that balance between individual privacy and greater good. And committees of experts are asked to review each proposal, there's the ethics review boards, in order to ensure that there's appropriate balance of individuals' rights to have their sensitive information protected versus ways of aggregating that information for the greater good. And I just feel that while blockchain has many features that can enable privacy, those regulations are in place in order to protect individuals and allow them to make autonomous decisions about how they want their information used. Or there are some circumstances whereby information can be used for public health surveillance and for certain forms of clinical research without their active consent. However, there must be close oversight by those institutions conducting the research in order to ensure that individuals' rights are still protected. So it's a very difficult balance, and I would just encourage all individuals to be respectful of those difficult decisions, but always keep the ethics of the individual in mind. Thank you.
Great. Mike?
This is going to be interesting because I'm coming from the exact opposite viewpoint on I'm a Canadian. I grew up in Canada, but then in 2005 moved to Asia, lived in China, South Korea, now Singapore. And so
I went to school at McGill.
Oh, nice.
I'm a McGill guy.
Nice.
Go ahead.
We have a great healthcare system up there, and everybody says how if you're American, Canada has a great healthcare system. But then when I was in China and then mostly in South Korea, now Singapore, the healthcare system here is absolutely amazing. Now, when it comes to individual rights versus collective, I'm in a collective society. I've lived in a collective society now since 2010, first Korea and now Singapore. When COVID broke out, I was on a flight from Canada coming back from vacation, coming to Singapore. My flight got canceled because that's when borders started to shut. Singapore shut off to Korea, which I was flying through. I had to scramble with my kids, fly into Singapore. Long story short, about 3 weeks later, I came down with pneumonia. And then I was put into the NCID. It's public on Facebook, my whole what happened that day. And it was quite an interesting experience because Singapore's taken the collective route, right? What's best for society? And I spent 5 days, countless COVID tests. This is when they didn't know even really how it spread. How do you have it? How do we even know if these tests are accurate? I had 9 tests that went through. I basically became a human guinea pig for them to try to figure out where actually can you get COVID or where can we test to get it. It was quite the interesting experience. So Singapore healthcare is absolutely amazing. The hospital system is very efficient, and we've had like 26 deaths. The society here, everybody was in lockdown for like 3 months. Our company, we're working remote now because we can't justify why are we going to put everybody in a room together when we're just going to be on Zoom call anyways. And so in a collective society, we can see the advantages as well. And especially when it comes to healthcare, I, for one, would donate all my healthcare information for tests. I think should occur. If it's going to start saving people's lives or get us to solutions faster, I think that everybody should just be, when I get a blood test, I was actually hospitalized this morning. I got out of the hospital a few hours ago with something that was found when I was in during the COVID period. But luckily I'm here right now, and it came, all my information was digitalized. Everything could be shared. And when it was COVID, everything, if they started sharing that globally, I'm sure we would have been able to come to ways to prevent the spread faster. And so I'm one for that. It should be that we should look at the collective. I think we should preserve the rights of individuals. Like, for me being Canadian, I don't like insurance companies working with them when all they want to use our data is to give people insurance and say, oh, we're going to advertise to these people because we think they're in a good category, that they're not going to be sick. And oh yeah, we're going to try to get this data, so we're not going to advertise this other group, because that's not against the law. It's just denying people based on data is against the law. So they always try to find ways to get around this. I hate that personally. And I don't want our company to be dealing with that. And I think that's where regulation should be around. Should say, hey, insurance companies, you can't deny people universal health care. And then people won't be afraid to share their data. With healthcare data, if you can respect the rights of the individual and make sure you don't cause them harm, like denying them healthcare, denying them services based on those things, then we can share it more easily. Then you don't have to worry about the ethics of sharing. You just worry about the ethics of what is done with the data. And that's where I really wish the debate was not trying to tell people that it's bad for companies to have your data. It's bad for pharmaceutical companies to have your data. It's just bad for them to, discriminate against you based on that data.
Yeah. So I think those are two really, really interesting perspectives. I can, maybe I set the question up incorrectly, but I can tell, I don't know. I have myself a personal litmus test, and that is the data that I generate should always serve me and not serve somebody else and harm me at the same time. So the idea that somebody knows that I have, let's say, this genetic disease in my family, we should never, like you say, allow the insurance company to use that to determine premiums for me and my family members, right? So that's the test that I sort of judge everything by, whether it's regulation or whether or not it is whether I actually contribute my data to a particular endeavor. So I think that's really...
I just want to add one thing about the litmus test. I think the same thing is that governments and regulation should do better, make the lives of the citizens better. And so using like your genetics, it should be used to make your life better by helping find a cure or warning you, or a new drug comes out that can solve that, then you're alerted on that. But so it does you better. But if all of a sudden it's used to like cause your premiums to go up, that's worse, right? So same thing. It's the same litmus test.
I'm going to steer the conversation back to blockchain.
Yeah, that's what I was just about to do.
Blockchain can enable the dynamic consent that I presented on earlier, so that we can give people choices of how their information is used. And while Mike feels very comfortable sharing his information, other people may not. And I believe that the more ethical solution for our society is to give people more choice and to create the technologies that enable them to have a say and be able to change their mind as well, if circumstances or perspectives change.
Excellent. I completely agree. So this is my blockchain exit, and very current, and I'm sure you can even answer with a yes, no. But in the current situation with COVID and more or less, the need to very quickly learn about what is happening in a way that actually threatens privacy in some ways, by having to share location data, information about yourself, and to do that all very quickly, you can answer yes. Do you think blockchains might help in this consent / ID / data exchange sort of, challenges that would be part of that type of solution? We see these in the warning apps. And with that, I think that's going to be the close.
The country of China used blockchain to help manage public health surveillance information, and showed that blockchain is a successful solution for data sharing and management. the whole concept of the new public health initiatives about emergency authorizations to share information is debatable. And the degree to which people might have their information shared in ways that they do not provide permission is also a matter of debate. I do believe that blockchain capabilities with dynamic consent and increased transparency at least allow individuals to have a voice and a view of how their information is used, with the hope that they can at least understand and have more trust in the underlying basis. Thank you.
Yeah, so I think those two V's were very important, that they continue to have a voice and they have a view of what was done. And that sort of contributes to, I think, what we have been saying, that a certain transparency is absolutely necessary to collaborate. And Mike, yes, no, or something more?
The dynamic consent and transparency, blockchain will help enable that and build the trust in the network so we don't go too far the other way and stop sharing data. So people can trust it and they can always have a say from now until the end for them. That will allow us to, that will enable more data sharing. So yeah, blockchain is a very pivotal technology for that.
Excellent. So I want to actually bring the session to a close, if that's okay with both of you. There's one thing that I must do before we leave, and that is to thank not only all of the presenters, which I've already thanked. I want to also thank the European Commission in sort of making this possible. And there are a number of other entities and institutions that were partially responsible for making this happen. I won't name them individually so that I don't omit anybody, but they should know who they are and they should know that we are grateful. So thank you. Great.